Hello everyone and welcome to the Introduction to Photon workshop. So this workshop is scheduled to be about 2 hours long. I'm pretty sure we'll end up going over that, but we'll do our best to keep the time limited to around 2 hours. Your lead instructor for today will be Mr. Nelson LeKay. Say hello, Nelson.
Hey.
All right. Also joining us, we have our TA, Mr. Gavin Whitlock. Hey, Gavin.
Good day, sir.
Good day. And myself, Jason Busby. Most of you know me as Buzz, around 3D Buzz. So, this workshop is a little bit different than our extended classes, and this is how all the workshops for the most part are going to be. That is, there's going to be loads of instruction, not a lot of following along, because we want to try to get as much material as we can into the workshop. The other problem is, of course, if we spend the first hour with everybody getting set up here, that will result in us having to go on for 4 hours for sure, and there are some people that simply want to get this material and get out. So we're recording the video, we'll put the video up for member sponsors afterwards, and then you guys can go back and follow along. But the goal will be to have a completely functional application by the time we get to the end of the class, making use of Photon. We do want you to ask questions. Have fun with asking questions, lots of questions. Because since you're not going to be following along, I want to make sure that we get as much stuff as we can answered for those that are trying to follow later so that things go smoothly for them, including you guys. And I think that's pretty much everything.
Well, we have actually had one introductory question already, which is this Photon in general or Photon plus Unity?
No Unity. Go ahead, Nelson.
Yeah, we're just going to be basically putting together a just a little chat application with multi-room support. So we're going to be talking about how to set up Photon, what are the main sort of things you need to write in order to plug into Photon, both on the server and the client side, and then some techniques that we can use to make working with a network system a little bit nicer. So, yeah.
Yeah. So let's go ahead and kick things off, Nelson, with what is Photon? Let's pretend I'm new to this. What is it?
Well, Photon really just is it's a server. It's basically an application that provides an abstraction over the concept of connecting two computers together, and that's it.
So just two computers?
Well, it is highly...
Not too many.
Yes, exactly. You can certainly connect quite a few computers to a Photon server. It supports quite a few different, or quite a large amount of connections, and it does so in a very performant manner. And the idea is that you write your own application, your custom application in C#, and then plug it into the Photon engine, and it deals with all the network stuff for you.
Okay.
So
now, why would we want to use something like this instead of just doing our own low-level networking stuff?
It's just about saving time, really.
Okay.
Photon provides a lot of features, and not just features. It makes it so we don't have to write a lot of code in order to get started writing reliable, high-performant network applications.
Okay. Not to mention that there's been a tremendous amount of testing, and it's being used in production in multiple games. Security. That's obviously a very important thing as well. And it's nice letting somebody else worry about that than us having to pull out all of our hair, because I don't have a lot of hair left to pull out. Trying to make sure that every possible exploit has been closed up.
Yeah, so basically what we're going to be doing is we're going to be installing Photon. And we're going to be installing it, getting it up and running, and writing an application built against it.
Now, there was a question that came in over in the questions panel from Segslot asking, is it client server or P2P?
It's client server. Okay, so to install Photon, now I do want to point out, Photon does come with a free 100 concurrent connection license.
That can be used in production.
Yes.
Which is amazing, frankly.
Okay, so what you're going to want to do is you're going to want to click on the Download Now link. That's going to redirect you to a login form. You do have to register with Photon to get your licenses. And for some reason... My internet connection's very slow today.
We can all see you signing in.
Yes. If I can remember my password.
We can all see you signing in wrong.
Okay,
Yeah.
so after you register and sign in on exitgames.com, you will have a bunch of stuff. What you're going to want to do is you're going to want to grab the Exit Games Photon Server SDK RC9.
Now, before you do that, Nelson, if you guys take a look on the right-hand side with client SDKs, you'll see that this is a very well-rounded out application/API. I mean, it supports iPhone, it supports Unity, it supports Android. It's actually quite impressive. Windows Phone also.
I'm also impressed that they've made it so obvious which ones you need, because that's not a given. The sites that you go digging through looking for which version of what do I need to download.
Yeah. I do want to point out a few other things, though. Photon actually supports quite a few different transport protocols. Blah, blah, blah. I don't know if we're going to get a listing anywhere on the site, but what comes to mind is it supports, it's as a socket server, which supports TCP, UDP, obviously. It also supports WebSockets, which, if you're not familiar with WebSockets, it's basically sockets that are available to developers who are writing web applications. So through HTML and JavaScript, you will be able to communicate with Photon real time through a web application. So it's a very interesting, platform.
Without a doubt.
As far as Photon Cloud sort of irritates me because with Photon Cloud is my understanding, and I haven't read anything that indicates that this isn't true, but it's my understanding that Photon Cloud is only a deployment of the light Photon application, and that you will not be able to write any server-side logic.
And obviously leaving all of your logic for the client side is bad. Very bad.
So I was a bit disappointed when I found that out. However, if you're writing a first-person shooter or a racing game or something very straightforward, it is very competitively priced. So I will give them that.
What does the acronym SAS stand for again? I can't remember. I did know.
What?
Exit Games Photon Cloud is the fastest SaaS network engine.
Software as a service.
Ah.
Okay, so now that you have Photon downloaded, hopefully, you're going to have a zip folder that has this stuff in it. I'm going to go ahead and dump all of this into a directory on my computer. It doesn't matter which directory I do dump it in. So I'm going to go to C software, and I'm going to dump it right here. And I'm going to say C software, Photon, and I don't really like this name. I'm going to do 3-RC9, and then Photon. There we go. That looks nicer. Then I'm going to simply extract everything that came from that zip.
And to answer Wolf Knightley's question real quick that was asked over in BuzzMed, he said, did he say that you have to pay to not have it run client-side? Now, basically, there's two approaches that you can take with Photon. You can run it on your own dedicated server, or you can use their cloud services and run it with their cloud services. But if you're doing that, it's not your own server, and they don't let you put code on their servers. So you're limited to what is called light game, which is something you'll become familiar with here in a few minutes. And you're left to handling all of your logic on client side. So in most cases, I would think, you'd want to run it on the client side. I'm sorry, not in the cloud. That's what I was looking for. And so, yeah, there you go. Oh, yeah, and I know
essentially you're going to end up paying for bandwidth one way or the other.
Well, you're going to end up paying for
bandwidth.
But what I wanted to point out is, again, with 100 concurrent license for doing it on your own server, just, the thing's going to be you're going to need to come up with your own dedicated server. But, again, you get 100 concurrent connections for free. Okay, Nelson, so that's all unzipped now, unzipped. I just can't talk today. I guess I need to drink more coffee.
You just need to drink more. Dane did bring up a good point, which is, so can you run it on an Amazon server? And replacing Amazon with any other is probably well worth a check through their EULA to make sure, depending on what you're running on it, that they don't have specific caveats against using it with multiple connections.
I think
because it depends on what you've bought from where and whom, and it's going to be...
No, I would say, Dane, that, yeah, I don't think it'll be a problem at all to take advantage of that. Yeah, as MMO Dust just said, should be no issue with running it on EC2. I completely concur.
All right, so is everybody ready to learn about Photon?
Let's do it.
Okay, so Photon, I'm just going to extract it. I've extracted 4 folders. Very straightforward. We have deploy. Deploy contains 3 important groups, or 4 important groups of things. You have your bin tools, which contains just a bunch of random tools that come along packaged with Photon. We're going to be using Beartail, for example, to look at logs. It comes with these bin binary folders. These binary folders correspond to your operating system. There's a bin Win32, bin Win32XP, bin Win64, bin Win64XP. I feel that that should be fairly self-explanatory. They are all very similar in what's actually in them. They're just different builds. However, to avoid myself getting confused, I'm going to go ahead and delete every binary folder that isn't bin Win64 because that corresponds to my current operating system.
So presumably the non-XP ones apply to NT, any NT based, as opposed to just Windows 7, or?
I think so.
I'm thinking Vista, or?
I doubt that Photon supports anything before XP, so I imagine XP is for XP, and then the bin Win64 is for 64-bit Windows 7 or 64-bit Vista.
Cool.
Okay, so next important thing is going to be the applications. These are all the applications. Like we were talking about earlier, Photon is an application that we plug our own applications into, and they get placed into this deploy folder. This deploy folder is ultimately what you're going to be putting on a server. The last thing that's going to show up here once we start running our application are the log files for our applications. So we're not going to be worrying about light lobby, load balancing, MMO demo, or policy. But that does bring us into the next interesting thing, which is source server. I know I'm jumping down a few items here, but source server will actually correspond to what we see right here. If you jump into source server, you'll see, well, the source code for all these applications.
You need to click a little slow. You're
He's
clicking faster than the frame rate.
Oh.
Right.
Well, yeah, it doesn't require too much explanation. So, for example, light, here's the solution for light. Here's all the code for it. I like that they packaged that stuff along with the Photon distribution because it provides some really nice documentation type things while you're working with Photon. It's nice to be able to jump into light or MMO and
It's always nice to be able to jump into something that is, well, supposedly guaranteedly works.
Yeah.
And go, oh, I see, I've missed a -1, or... You know,
And now these things like light lobby, MMO, these are basic starting points if you would like to, you know, already have a framework in place that you can then build onto.
Right. And like we talked about earlier, light is what is what's available on the Photon Cloud. But
well, so can you give us a brief bullet points of how they differ then? The ones that are there?
Counter publisher and load balancing and policy are all sort of infrastructure type things. Like counter publisher is for, well, publishing counters, performance counters. We're not going to be talking about performance counters. Load balancing is, well, obviously load balancing between 2 Photon servers. And then policy, which is an application used for certain security requirements when requesting resources over the web. But as far as light lobby, and MMO, light is basically an application that has a concept of actors and rooms. is actually going to be very similar to what we're going to be putting together today.
Actors?
Yes, actors. Light lobby, again, it's a similar thing, just that you have a lobby as well, and you still have rooms and actors and stuff. MMO has things like, I haven't actually spent a lot of time looking in the MMO, but I do know it supports a lot more complex.
Yeah, it has the interest management system already established for you, items, NPCs, etc., that you can then build off. Again, it's just a framework to get started with creating an MMO using Photon.
All right, so yeah, that's source server. Then we have doc, which should be fairly self-explanatory. Doc is just the documentation. So
How good is the help manual?
I haven't spent very much time in these at all. I typically just search online for stuff, but I have spent a lot of time in the Photon configuration PDF, and it is very straightforwardly laid out.
Now, you showed us on the site that there's different sort of clients for different distributions, platform-wise. But does the servers only run on Windows platforms?
To my knowledge, do you have any thoughts on that, Jason?
I'm sorry, say the question again.
It's as regards Hector's question.
Oh,
Does it only run on Windows platforms server side?
ooh, that's a good question. I'll look into that while Nelson's talking here. I don't remember. I haven't needed it for anything other than Windows.
I would probably say yes, and the only reason is just deducing the fact that they only have one SDK download link, and that the SDK itself contains native code, which means it's not like it's completely managed so that it could run on different platforms without recompilation.
Right.
Okay, so yes, documentation, very straightforward stuff. Yeah, and it's also broken, it looks like. Really? Huh. This is actually a new version of the release candidate. I actually have been working on RC8 for a while, and RC9 just recently came to be, and it looks like their docs are broke. I have to unblock. Oh, really? Oh, come on, Windows. Alright, thanks for that. Never mind, it's not broken, ignore me. But yeah, so here's documentation. Okay, so then we have lib. Lib is very important. Lib is going to be the libraries, the .NET assemblies that your server and client applications are going to need to reference. I mean, obviously, you'll need different libs for other platforms that aren't in C#, but this lib folder will contain the libraries for your server as well as for C# and Unity clients. You'll notice, I'm going to go ahead and filter by assembly. You'll notice we have things like blah, 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 Photon socket server, and it looks like they moved their WebSocket server into a different distribution package because in RC8 there was also a Photon.WebSocket server, but it looks like that was moved somewhere. And then you'll notice things like Photon3.net, which is the .NET library, and then you also have Photon3 Unity 3D, which is the .NET library that is specific to Unity. I'm not sure why they have to have two distributions, but I know that using the Photon3.net DLL inside of Unity will cause misery.
Presumably they've locked out anything that makes Unity blow up.
Yeah, but
it's an old, almost legacy build.
But
I know it's not the subject of this, but how did you filter those by?
Oh, it's you click on the little down arrow, and then you can do that.
Okay, cool. Thank you.
But yeah, so that's the lib folder. Very important folder. Okay. don't know what else to say at this point besides actually going ahead and launching Photon and seeing about getting an application built against Photon.
Yeah, let's do it, man.
Okay, so
Make me a website.
So what you're going to want to do is you're going to want to use the PhotonControl.exe. In fact, I'm going to go ahead and pin that on my taskbar because it's a very important executable. I do want to also point out...
What does it do?
It allows you to control Photon. I want to point out there's two ways of messing with of controlling Photon. You can use Photon as an application or Photon as a service. So, for example, you can install Photon as a service. For a server, you would want to install Photon as a service to ensure things like it starts back up when the server restarts and all that good stuff. But for development, I find that it's a lot more useful to treat Photon as an application because it's something I can start and stop whenever I want. So when you launch Photon Control, you're going to get this nice little icon down here in your tray. And you can drag it down there. And by right-clicking on this icon, you get a nice little control panel. So you have things like Photon Instance 1 is what you're going to want to be dealing with. Photon supports multiple what are called instances. We're not going to be worrying about that. We're simply going to be using the default Instance 1. And you'll notice
that's for simulating multiple servers.
Yeah. And then you also notice that there's another instance for load balancing and stuff like that. So the other interesting aspects to this control panel, besides being able to start an app as application, which you're going to be doing quite frequently, there's also the Explorer working path, which will just open up a nice little Windows Explorer window to wherever you have installed. That becomes very handy. And you also have open logs, which open logs will go ahead and open up Beartail and the Photon CLR log. I'm not going to start Photon yet. And the reason I'm not going to start it yet is I'm going to actually unconfigure the default applications after we configure our own custom application. So I'm not going to worry about starting it at the moment because that's going to do nothing but just start a bunch of applications that we don't have clients for. So instead, I'm going to go ahead and start a new solution. And I want it to be a solution, which I guess you can't do in Visual C# Express. So I'm going to go ahead and cheat. I'm going to create an empty project called Photon Test, which will conveniently name the solution Photon Test.
And then nuke it.
And then I'm going to delete the project. There we go, that worked. Okay, so I'm going to create 3 projects. I'm going to create a class library called PhotonTest.Base. I'm going to leave the class 1 in there. PhotonTest.Base is going to be for... I'm just going to get rid of these toolbars. These toolbars are really irritating me. PhotonTest.Base is going to be for code that's shared between the server and the client projects. The next project I'm going to add is going to be a console application. PhotonTest.Client, which not surprisingly is going to be the client. And Control W isn't bound, right? Okay, so then PhotonTest.Client, which again is going to be the client, console client thing. Then I'm going to, now this is important, I'm going to create another class library called PhotonBase.Server. This is going to be the assembly that we're going to be putting into Photon. So I'm going to go ahead and call this PhotonTest.Server. Okay. There's a few important things that we're going to need to do here. The first thing is we're going to need to reference the appropriate Photon assemblies for each one of our applications. So to do that, I'm going to jump into the lib folder and I'm going to grab the appropriate DLLs and blah, 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 blah. And I'm going to jump into the solution. Underneath the solution, I'm going to create a new folder called lib. And then I'm going to create a new folder under here called Photon. you always want your assemblies that you reference in your projects to be placed relative to the root of your solution for a variety of reasons.
Are lib and photon case sensitive? Are they required to be in lowercase, or is that just your personal preference?
That's typically my personal preference. I don't know.
I just didn't know if it was, it will only look for lowercase or not.
No, it can be anything you want. This is just an arbitrary folder. So it's an arbitrary folder that I place dependencies that my solution may have. It's incredibly important that they're relative to the base of the solution, mainly in regards to source control. Because when you package up your project in source control and send it to somebody else, if you have library references that are absolute paths, obviously that's not going to work on other people's computers. Furthermore, if they don't have those libraries on their computer, then, well, what is it going to reference? So I'm going to go ahead and dump pretty much everything here except for Photon 3 Unity 3D, Photon Socket Server NUnit, and NUnit Framework. So I'm just going to copy them over into a folder that is relative to my solution folder.
So all the files that aren't specific to Unity or unit testing.
Mm-hmm. I know they didn't make log4net. Log4net's free.
You shouldn't
open
be
source.
reading that. Ignore segfault. Well, actually, while you've stopped, so your workstation/server doesn't need to be running something like IIS?
No.
Question mark?
No. Photon. Think of Photon as a very similar thing to IIS. I mean, what do you do with IIS? It's an application, you launch it, and you plug in other applications that you write into it. You don't need any additional software on your computer to run Photon. Photon is completely self-contained.
Mr. Complicated, I'm getting to it, but it came in after Barry's question that I just asked, Nelson. Request to slow down a second to catch up. Probably not. If you missed the beginning of the meeting, these aren't the same as the live classes. We're trying to get through the information in a limited amount of time, as much information as possible. So we'll be just letting
make sure
Nelson type at his actual speed, for instance. Jason?
No, I was just going to say the video will be made available online, hopefully shortly after it is done, so that those of you that want to go through and follow. I mean, if you're able to keep up with Nelson, then I say go for it. But just try to watch and feel free to ask questions as we're going. But with these shorter workshops, we're not doing everybody following along because it'll result in becoming a bit of a mess, because we don't have 6 weeks of doing this. So go ahead, Nelson.
Okay, so now that I have the assemblies copied over into that path, I'm going to go ahead and reference the appropriate assemblies from the appropriate projects. So Mr. Client's going to get, he's going to get...
Are you really doing the Mr. thing again?
Yes. He's going to get log4net and photon3.net. Those are the only two assemblies that he's going to get. PhotonTest.server is going to get exit games logging log4net, exit games libs log4net, Photon socket server, and Photon host runtime interfaces. So basically everything that, everything else, including log4net. Okay, so now that we have these references in here, what we can do now is we can create a type, a class within our server project that inherits from a class that's provided by some of the assemblies that we just imported. So I'm going to go ahead and this is going to be so much fun. I'm going to go ahead and create a class called application, and I'm going to make him a public class. And then we're going to go ahead and inherit from application base. Now, application base is a class provided under the Photon.socket server namespace. And then I'm going to implement his members. So we have 3 members. The application class is the main class that's loaded into Photon. I mean, in fact, the application class is the only class that you have to explicitly tell Photon in the configuration that it exists. Every other bit of interaction that's dealt with through Photon is handled through this class. So you'll notice we have 3 methods. These 2 should be self-explanatory: setup and tear down. Setup is invoked when your application is started, and tear down is invoked when your application is terminated. However, create peer is interesting. Create peer is a class that allows you to inject custom implementation of what's called a peer into the system. A peer is basically the representation of an individual client from the eyes of the server. So every client that connects to a server gets an instantiation of a peer class. And because of the way inheritance works, we can actually, when we can override this create peer method to actually return an instantiation of a custom peer class that will provide our functionality for dealing with peers. So let's go ahead and create our peer class.
That takes in an init request.
Yes. An init request contains, and of course I don't have a decompiler right now, but an init request contains things like local IP, local port, remote IP, remote port, protocol, stuff like that.
And just that presumably defined somewhere inside of Photon.
Yeah, init request is Photon socket server.init request.
Cool.
Okay, so in our peer, not surprisingly, we're going to create a class called peer that inherits from peer base. And then we're going to implement peer base. Peer base has 2 important methods. I'm actually going to go ahead and remove that, and there we go. Get it using in there instead. Peer has 2 methods, as onDisconnect and onOperationRequest. OnDisconnect, again, should be very straightforward as to what it actually does. OnDisconnect is invoked when the peer is disconnected, when the client disconnects from Photon. I do want to point out just really quickly as an aside that it's very difficult to, in network programming, to identify if a client has disconnected from a server. I don't think people realize how complicated and miserable it is to deal with network stuff at a low level when you have to make a lot of educated guesses about whether or not the client's just being quiet or if someone tripped over a network cable or whatever. So the fact that Photon handles disconnects in a very graceful manner is a very nice thing to get out of the box. I mean, you might want to take it for granted.
The amount of time it takes the average person to make a cup of tea needs to be factored into whether they're actually disconnected or whether they're just paused.
Right. And Photon handles it very gracefully, so you don't even have to think about it. So this method is actually something that is very interesting, even though it looks a bit mundane on the surface. Okay, onOperationRequest is another very important method. Basically, so I previously defined a peer as the representation of a client from the eyes of the server. But there's also there's a class called Photon peer, which is the corresponding client representation of the server. And when a client connects to the server, what they can do is, okay, so a client connects to a server, the server instantiates a peer for them. And then when the client asks the server to do something, the appropriate onOperationRequest method of that particular peer instantiation gets invoked. So this is the method that you will be handling requests from the client. So you'll notice, like, for
So basically, everything that the client asks the server to do is an operation, basically.
Yes.
Cool.
So for example, if we look at OperationRequest, we have 2 important parameters. We have operation code, which is just a byte. That's just an extra byte that gets sent along with operations to differentiate different operations. And then we also have parameters. Parameters is a dictionary of byte and object. This is going to be data that's been sent from the client, serialized, shot over the internet, and then reconstructed on the server into a dictionary of byte and object.
So operation code is like an ID for that request.
ID for
type of that request.
Yeah, type of the request. So if you want to say move, you would have one operation code. If you want to say jump, you'd have another operation code. Okay, so now let's go ahead and make our application, or actually, I don't have Resharper installed, sadly, but we are missing one more thing that isn't immediately obvious, and that is when inheriting from peer base, you must invoke the base constructor with an IRPC protocol and an iPhoton peer. Fortunately, both of these things are provided via the init request, so I'm simply going to have my peer take an init request in the constructor, and then it's going to invoke the base constructor with init request.protocol and init request.photon peer.
Andrew did ask, are you limited to 256 operation codes?
Well, yes, but there's nothing stopping you from creating an operation code that says, well, look at the first parameter in the dictionary for another operation code. However, you'll notice with what I'm about to put together, we're not going to be using operation codes very much, and that's going to actually require a discussion about serialization, which we're going to be getting to.
Oh, and does it use pinging?
Presumably, I would guess that it does. Okay, so now that we have the peer, I'm going to go ahead and delete the setup method and the teardown method, and the create peer, I'm simply going to say return new peer init request.
Sorry, did you say? Oh, I see. What you mean? Delete the contents of the setup? And
Yeah, because they were throwing exceptions, which is not ideal. Okay, so what we have right here is the bare minimum of a Photon server. This is it. If I compiled this, configured it with Photon, it would run. Although it wouldn't actually do anything. What I'm going to go ahead and do is we are going to be using Log4Net. Logging is a ridiculously important aspect to server applications, particularly because server applications in this context are headless. There's no way to monitor them except through something like a log. And so they're incredibly important to monitor your server. If you are not looking at your logs of your server as you are developing a server application, you will, well, you just won't ever find out what's wrong with your code. And that's it. So what we're going to do is we're going to set up Log4Net, and I'm not going to discuss a lot about what Log4Net is or what it does. That's a potential workshop coming up, but if people are interested.
But it has been a past workshop that we have recorded that is also available right now. So
yeah. Okay, so in the setup method, what I'm going to go ahead and do is I'm going to try to locate the log4net.config file. So basically that means I'm going to say path equals path dot, or path, I want my Resharper back. Combine. Now I'm going to say binary path, comma, log4net.config. What is binary path? Binary path is a property provided by application-base that will point to where the binary of your application is located. Because Log4Net is going to accompany the compiled DLL for this PhotonTest.server, we can safely attempt to locate Log4Net by combining binary path with log4net.config. Next, I'm going to go ahead and turn it into a file info. And actually, why am I even doing that? I can just do that. Okay. So now I'm going to say if file.exists, what we're going to do is we're going to say exit games logging log manager set logger factory log4net logger factory dot instance, and I'll explain all this in a quick second. XML configurator, I love that word. Configure and watch file. Otherwise, basic configurator configure. And then I'm also going to say private static ilog log. And then at the end of this, I'm going to say log equals log manager get logger type of application dot, what am I doing? I'm just going to make dot. That should be fine. And then I'm going to say log.debug application started. Okay, so what does this code do? Basically, the first thing is we get a file info instance of the potential log4net.config. We check to see if it exists. If it does, actually, I really wanted to move this up there, so blah, 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 format this better. There we go. Okay, if the file exists, we will inform log4net to use the XML configurator to configure and watch that log4net.config. Cool thing about that means we can update the log4net.config during runtime to either have our logging be more or less verbose dynamically, which is a very nice feature. Otherwise, we do the basic configurator.configure, which just pipes the output of log4net into a console window that doesn't exist. Then we go ahead and say log equals log manager get logger type of application, which simply assigns our log to an appropriate instantiation of a log4net type that represents the log that we're going to be logging to. Finally, on line 33, we log out the words application started. Up here, I'm going to go ahead and say log.debug, actually debug format, I'm going to say peer from connected. I'll say init request remote IP. So this is it for now, at least as far as our application. The reason I wanted to get this up and running right here was so that we can actually watch our application do something when it started. However, I am going to go into peer and I'm going to instantiate a logger. I'm going to private static read only ilog log equals log manager get logger type of peer, because we will be using this log a little bit later. The last thing I'm going to have to do is create a log4net.config file. So I'm going to go ahead and say log4net.config, and I'm going to cheat and grab an existing log4net.configuration file and modify it. Okay, because this is not important. Actually, well, the only thing that's important to this is to know that there's going to be two log files. There's going to be PhotonTest.root and PhotonTest.app. PhotonTest.app is going to contain all of the log messages that are logged from anything under the PhotonTest namespace. And PhotonTest.root is going to print out everything that is logged from things excuse me, things like Photon itself, or stuff and things. So anything that isn't from the PhotonTest namespace. I like delineating the two because sometimes Photon will throw up a bunch of verbose information and it'll drown out my application-specific logging.
Just how... See, the thing is, just how wrong would you be to say, oh, I'm not going to need this, let's just not bother with all this log4net stuff?
What do you mean, not going to need?
What I mean, is it... I suppose, obviously, you'd be mad not to log things, but it will Photon throw a wobbly if it's not there. I guess
No.
asking.
We could have just as easily launched this application without logging, but I wanted to show people how to get logging set up anyway, and I also wanted to have something happen when our server starts.
Yeah, I just wanted to... I didn't know if it would be upset by the lack of logging.
No. And you'll notice here on line 25, what I'm doing is I'm telling Exit Games has this weird log manager thing that's an abstraction over logging. So it supports different log frameworks, and you have to tell it which log framework you want it to use. Okay, so let's go ahead and run our application. Is everybody super stoked?
Woot.
Because we finally have enough stuff to cause Photon to start an application and to actually see it started. The first thing I'm going to go ahead and do is I'm going to change my build path. Actually, I'm going to back up really quickly. I'm going to be doing something that is specific to my computer, which...
Rebuilding it?
No, where are you? Is this... Wait a sec, is this a joke?
What have you lost?
Well, I guess I will not be going over build configurations today. Because so basically what I'm going to be doing is I'm going to be building out the server application directly into the Photon, the folder where it needs to be. The reason I do this is just simply a matter of convenience. Every time I hit Control-Shift-B, Visual Studio will place the assemblies in the appropriate location underneath Photon. The downside to this is specific to my computer, and there's a very elegant way to handle settings that are specific to an individual developer's computer, which I will not be able to showcase because apparently Visual C# Express does not support it. Okay, so let's go ahead and dump this into a folder. So what folder do we need to dump this into? Underneath deploy, I'm going to create a new folder called 001 Photon Test. This is going to be my application folder. Underneath my application folder, this is important and required. You will have a bin folder. Underneath the bin folder is where my server application will be built to. So now when I hit Control-Shift-S to save the project file and Control-Shift-B, and I jump into my blah, 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 blah.
You turned it into a horrible relative path.
Oh, yeah. I'm going to go ahead and jump into Photon Test, and hey, look, here are all of our assemblies. The most important one being PhotonTest.Server, because this contains the code that we're going to have Photon be interacting with. Okay, so
I know it's not.
What?
I know this isn't about Photon with Unity specifically, but just a quick kind of nudge to anyone who uses Unity. That rebuilding process that Nelson just did there, you can think about it if you've been wanting to build in other projects outside of Unity. Just point your output path to the relevant to the assets folder inside your Unity project, and boom.
Yes.
So anyway, I was pleased to find that out a few weeks ago, so I thought I'd pass it on. Carry on.
No, it definitely does make dealing with some of Unity's wonkiness bearable. Okay, so yeah. Now the final thing we need to do is we need to go ahead and configure Photon. So how do we configure Photon? Well, there's a nice little file that's very well documented called photonserver.config. Now I'm going to go ahead and click and drag it over into Visual Studio because Visual Studio has syntax highlighting for it. And I am not going to be going over every single one of these things. This is, like I said before, this is very well documented. There's a PDF that's specifically about this, located under doc photonconfiguration.pdf.
It does look very well commented as well.
Yes. Okay, what am I going to do? I'm going to go ahead and I'm going to, first of all, I'm going to turn off my UDP listeners. I'm doing this because my VM is using bridged networking right now, and I can't remember if my host has anything bound to 5055 right now. Next thing I'm going to do is I'm going to go ahead and remove my TCP policy listeners. We're not going to be doing any TCP policy stuff. This is security features for web applications. We're not going to be doing any WebSockets, so I'm going to go ahead and remove my WebSocket listeners. Next up, I'm going to go ahead and comment out each one of these demo applications. So, with those all commented out, Photon is not going to be launching any application on runtime. However,
Can you collapse your comments, please?
You what?
Could you collapse your comment now?
Yeah. Well, actually, hold on. Let me grab a thing so I can copy and paste it.
I was just thought you get more on the screen.
Yeah. Okay, every application in Photon, you're going to need a application element underneath the applications element underneath the instance you are configuring the application for. In this case is instance 1. So I'm going to go ahead and say application name equals Photon test. Base directory is going to be 001 Photon test. Look familiar? That's the path that we set up right here in the deploy folder.
I was going to actually ask about that, given that you started with a number, which is usually a no-no.
Yeah, for directories that's fine, and I like doing it because it makes the sorting bearable.
Yeah, I didn't, but again, I didn't know if it was some. There's a lot of these things where I can never tell whether it's your house style or thou shalt, if you see what I mean.
Actually, I did notice something wrong about this bin folder. I forgot to set my log4net.config to copy if newer. So what I just did was made log4net be copied over into the bin folder because it needs to accompany the PhotonTest.server.dll. Okay, so the assembly is, not surprisingly, going to be PhotonTest.server. The type is going to be can anybody guess what the type is going to be? Come on, let's engage the audience a little bit.
It's not a battle.
Close, Segfault. The type is, like I said earlier, the application class is the entry point into Photon, which means the only information that we need to explicitly tell Photon is what type it represents our application base. Which means, is this going to be PhotonTest.server.application? Because that is the namespace qualified name to that class. Okay, next thing is enable auto restart. This is very important. Enable auto restart will actually, what it'll do is if it detects a file change in your application or in your bin directory, it'll actually trigger a restart of just your application and not of the entire Photon runtime. So it's a very efficient way to restart your application to get code changes in without having to entirely reboot your entire Photon instance. You'll notice that we say watch files equals DLL and config, which means that if DLL files or config files changes, that'll trigger a restart, but we exclude log4net.config because we already have that configured to be automatically reloaded by our application. The last thing I'm going to do is I'm going to add one more attribute to this, and because I have an awful memory, I completely forgot what that attribute was. But if you give me 1 second, I'm going to find out for everyone. If I had a PDF reader on my VM, I would be able to look at the documentation, but unfortunately I don't. So let me dig through my own Photon configuration file and find that fancy attribute. There you go. I'm going to say restart delay millis equals 1000, meaning it's going to check, well, not check every second, but once a change is detected, it'll wait a second before doing a restart. The default for this attribute is actually significantly longer, and it gets very irritating.
So that's presumably just to stop every single character being read, isn't it?
Yeah, right. Because otherwise every file, even because obviously there is a few milliseconds between starting the publish and ending it. I would not set this to 1. This is in milliseconds. Okay, so this is the only configuration that we need, actually. But I am going to go ahead and unconfigure our instance load balancing entirely. Or I can't remember if I have to or not. I don't know. Let's just leave it.
Comment it out for now, and then if it complains, you'll know that you were wrong.
I'm just going to leave it in there for now.
Bad mouse.
I know. Okay, so is everybody good for the configuration?
Stop reading.
Is everybody good for the configuration, what we've gone over so far? Because I'm about to hit the start button on Photon, which is inevitably going to result in a couple of errors that I'll have to resolve. I'm just throwing that out there. I don't think there are, but there probably are. So let's go ahead and watch Nelson fail. I'm going to go ahead and right-click on Photon Control, go to Photon Instance 1, and say Start as Application. Because it is a bat file that is launched, it's going to complain, blah, blah, blah. I'm just going to say, don't always ask me before I open this file, and hit run. Then I'm going to right-click again and say open logs. And what it just opened was the Photon instance log and the Photon CLR log. The Photon instance log is the native log. Oh, hey, look, it started. You'll notice that the firewall warning just popped up, meaning that Photon did successfully bind to a port. Okay, so this is the native Photon log, so you get a lot of verbose, native-y style information. This log is particularly important when working with applications that can't start. If your application throws an exception during initialization, it will make it so Photon can't even start. And the only place you'll see that exception is in the Photon instance log. The Photon CLR log is the managed log, so you get all the managed type stuff. You'll see a lot of stuff about app domains and stuff like that. Notice how we did create an application domain for our Photon application, our 001 Photon test.
Cool.
And let's go ahead and jump into where the log goes. Now, this is important to realize. Log for net.configuration, this is relative. So you see I do log / PhotonTest.root. But if you look closely into this log, you'll notice that the working directory, the application base working directory of our applications is the deploy folder. Meaning that when log4net writes to log / PhotonTest.root.log, the result is we get a new folder underneath our deploy folder called log with PhotonTest app and PhotonTest root. So let's go ahead and drag these logs over. Drag these logs over harder. Fail at dragging these logs over, maybe one at a time. Ugh. Let's go ahead and manually open these up from the open dialog.
Wow.
See, I typically use a program called Log Fusion, which I prefer a lot more. Blah, 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 blah. Okay, here we are. PhotonTest.app.log. Application started. Look familiar? That's coming from this, right here.
Excellent. I don't believe you. I think that you just typed that there to make it look like it was coming from there.
So watch that.
I give you an opportunity like that, and you're that uninventive.
No, I actually am. What I did was I added 1, 2, 3, and I did a Control-Shift-B, and I waited about 3 seconds. Notice we get application started 1, 2, 3, which means our application successfully reset itself. And if we look at the Photon CLR log, you'll notice that we get a new app domain. If we look at the Photon instance log, you'll notice that restarting application Photon test due to file changes.
Very nice. Well, we've been going about an hour, and I would say that's a good place to pause and see if anyone has any questions that they want to throw in over what you've covered so far.
Yeah, because the next step is going to be actually connecting a client and then actually talking about how we're going to get information passing between these two things. So we might be going on for a little bit more than 2 hours today. Okay.
So this is probably a good point. We just go ahead and take a break so that people can sit there and kind of think about, what questions they may have. And then throw your questions in the questions panel. And then when we come back from 10-minute break with the questions, 720 billion questions, Segfault, would take us an entire lifetime to start trying to answer. So if you could filter those down, that'd be awesome. But throw those questions in over there, and when we get back from break, we will we'll do everything we can to get those answered for you. So we'll be back in 10 minutes, guys.
All right,
Nelson,
and
go ahead.
we're back. So a few questions came in. Peer from connected. Well, this log message is not going to be displayed because we don't have any clients that are going to be connecting. Remember, a peer is the server's representation of an individual client connection. Meaning, if we have no clients connecting to the server, this code path will not execute. Therefore, this debug message will not be printed. If the server fails to restart, how will we be notified? That's entirely up to you. Typically what you would do in a production environment is you would set up an external monitoring application that would actually monitor accessibility to the server every X amount of time. Typically it's going to be a few minutes. And then that external monitoring application would notify you if it can't connect. I wouldn't worry about any other thing besides that level of monitoring, because if by using an external application to monitor the health of your server, not only are you testing to see if the server successfully restarted, you're also testing to see if it's successfully running and if the code responsible for establishing certain connections and whatever code you want to test is working as well.
So how do you monitor the monitoring software?
Well, at that point, then things just get ridiculous. By the way, if you want the configuration manager, you right-click on the solution. I don't. There just isn't a configuration manager.
Under properties.
Huh?
Under properties, isn't it?
No. There is no build configurations here for the Express versions. In the full versions of Visual Studio, you click on Build and Configuration Manager, but there's no build menu.
Oh, no. Well, I've always done it in the full version by right-clicking on the project. Going to Properties, or Build.
See, there's
Properties.
Even when I go to Properties, typically there's
an application.
Yeah, typically there's a.
Oh yeah, there's normally another tab.
Yeah, there's a drop down right here that allows you to switch configurations. That's not in existence at this point. Just to show people exactly what I'm talking about. So, for example, in a full version of Visual Studio, you can go to Build Configuration Manager, and you get this window. Or right-click Solution Explorer and go to Configuration Manager. Or when you right-click on a project, go to Properties, there's a drop-down for the current configuration. But none of these features look like they're implemented in the Express Edition.
Okay, well, that's that then.
Okay, a couple of questions in here. In the bin Win64, there is a 30-day temp license file. Does that mean we can only use Photon for 30 days? And when I download the Photon SDK for the first time, I download a license file. What is it for? Sure, let's go ahead and get the... Basically, when you install or when you grab Photon for the first time, it's going to come with an unlimited 30-day temporary license that will, like what I just said, suggests, it has unlimited connections, but it's only a 30-day license. If you want, what you can do is go to exitgames.com, log in.
Or just click on the big pink button that says free license download now.
But that's the free license though. What you want, or you would still have to log in basically because the licenses are associated with your account. Go under licenses, grab the free license, 100 concurrent connections, no expiry. Download that. Take this license file, this .license file, place it into the bin Win64 deploy folder, and then delete the 30-day temporary license. So now I only have one .license file in here. This is the one I downloaded. Now if I go over to Photon, I right-click Photon Instance 1, I hit Stop, then go back and hit Start. Now we're going to be using my...
license to 100 concurrent on, yeah, right, about halfway down.
Yep. And now we're started back up using my, and where are you again? It should say somewhere.
Two down from there.
Yeah, license for 100 concurrent connections. So now I'm using my new license. Okay, so is there any time that you would want to have more than one class in here from application base? No. I can't think of a situation where you would want multiple application bases, nor can I think of a situation where you would want multiple peers.
I was just going to ask about that because presumably you have different things like admins and
Sure, but
general users.
the problem is you don't, as of the connection time, you won't be able to know enough about the connection to even know if they are an admin. Basically, every peer starts out unauthenticated, then you write your own authentication layer on top of the existing peer, which we're going to be looking at.
Yeah. Cool.
Of course, when you get to your actual data model, then you might want to subclass things out. But the application peer are typically just going to be the only application base and only peer base. Okay, so is everybody ready to go ahead and create a client now?
Yes, because currently this is a very boring game.
Yes.
It doesn't do anything.
Well, we see how to deploy the server on a different computer and client on another. Not today, but as long as you get the IP address right, you'll be able to...
Everything else is the same.
What?
Everything else is the same. How you set up the folders at the beginning. I mean, it's really straightforward.
Yeah. Okay, so let's go ahead and start our client. I'm going to create a class. I like creating a class called Server Connection. This class is is a common abstraction that I use over connecting to Photon. The goal of this class is to wrap the existence of Photon into our own internal representation of how we're going to be dealing with our network application. There's a few...
So nothing outside of this knows about
the Photon peer. Exactly. This is the class that's going to be responsible for serializing and deserializing any request, turning them into a representation that makes sense to the rest of the program, and then going from there. Now, I'm going to have this inherit from a interface called iPhotonPeerListener. And I'm going to implement this explicitly. And the reason I'm implementing this explicitly is, again, I don't want this class to publicly know anything about Photon, but I want to be able to plug this class into the Photon peer. So I'm using explicit interface implementation. As a result, all of these members are private. I'm going to go ahead and create a constructor that takes in a string IP address and a string application name. The server connection is going to do a few things. The first thing it's going to do is it's going to alias out IP address to a field. Same with application name to a field. And then blah, 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 blah. Oh, come on. I want Resharper. And then I'm going to make these read-only.
I actually got to the point now where I find it incredibly frustrating watching you work when you haven't got Resharper.
Okay, the next thing I'm going to do is, this is very important. I'm going to instantiate a peer of type Photon peer. Now, the terminology does get confusing at this point because we also have peers from the server side. But a peer from the client side is the client side version of what a peer on the server side is. So this Photon peer is how we interact with connecting to a Photon server.
So essentially they both call each other a peer.
Yes. And you'll have one Photon peer on each client, and on the server you'll have one peer per client. Okay, it's going to take in a few interesting things. I'm going to go ahead and say that we want to use the iPhotonPeerListener as this. The iPhotonPeerListener is how Photon is going to interact with our client code. And because I have this class implementing iPhotonPeerListener, I can just pass in itself as the instance. Next thing is I'm going to say connection protocol equals TCP. And of course, Alt-Enter does not work. At least I can generate field stubs. Okay, next thing I'm going to do is I'm going to write a connect method. That's going to call peer.connect. The server address is going to be IP address, and the application name is going to be application name. Peer.connect is what ultimately is going to connect our peer to a server. It needs two things. It needs the IP address of the server and the application name of the server that we want to connect to. Remember that the application name is, we set that up in the configuration file to equal Photon test. Okay, I'm going to also create a disconnect method, which not surprisingly we'll call peer.disconnect. Then I'm also going to create an update method. It's going to call peer.service. These are the three methods that we need to work with the Photon peer. So I'm just sort of aliasing them out into their own methods on my abstraction of the server connection
So you need
class.
to be able to connect and disconnect, and you have to be able to be serviced.
Yes. Basically, peer.service is think of it like one frame of Photon's rendering. Peer.service will check to see if any incoming messages need to be received or if any outgoing messages need to be sent.
Hector asked, so in this case, service is a keep alive?
Well, yeah, it's what's going to, inevitably what's going to happen is, let's say the server sends in a message to our client in the form of an event. So when we call peer.service and there is an event being sent from the server, ultimately this is going to go through Photon's own processing and end up here on line 41, saying iPhoton peer to listener to on event. That's how we're going to be made aware of the server sending some information to our client. Okay. So nothing will happen unless you invoke peer.service. So let's go ahead and use our server connection. I'm going to say var connection equals new server connection. IP address is going to be 127.0.0.1 followed by the port that we have configured, which I forgot.
5,000 and something.
No, I disabled that one. It's 4530. And then we're going to be talking about the Photon test, which is the application name. Now, 127.0.0.1 is the loopback adapter. When I say loopback adapter,
it's a mirror, essentially. It fakes it
fakes it
back to yourself.
Yeah, it's a fake network adapter that just points to the same computer that you're on. Okay, so and then I'm going to say connection dot connect. I'm going to say while true, or how about while not console.key available, connection dot update.
I actually have never used that. It's key available. Presumably it's a bool. Any key? Which particular key? What?
It gets a value indicating whether or not a key press is available on the input stream. If I had done console.readKey, console.readKey is a blocking method, which would prevent connection to update from being invoked.
Yeah.
So this is just saying while we haven't pressed anything.
Oh, okay.
Okay, so let's go ahead and get our logs up. And I'm going to go ahead and hit F5. And I did not select the correct startup application. So I'm going to right-click PhotonTest.client and say Set a Startup Project. Now I'm going to run this. And hey, look at that. Peer from 127.0.0.1 connected. So this is the server actually responding to the client connecting. And if I press something, we disconnect. Which I can also go ahead and, in my peer class on disconnect, I can say log.debug format client or peer disconnected remote IP reason code reason detail. Okay, so I'm going to go ahead and rebuild the server. Remember, I made a server change, so I have to rebuild the server and wait for it to start. Now that it's started, I can go ahead and run again. And you'll see peer from 127001 connected, and now I see peers 127001 disconnected, client disconnect.
Sweet. How was it? What hotkeys were you using to auto do everything?
Auto do it. Oh,
Restarting and updating and.
I just Control-Shift-B causes a build to happen. A build will place the DLLs into the folder, which will trigger a restart.
So essentially, it'll restart every time you build, which you've got to do before it runs anyway.
Right. And then the application started message is very helpful because once you see it, you know you can go ahead and launch a peer or launch a client, and it's going to connect to the right application.
Cool.
Okay, so let's make things a little bit more interesting, I guess. What we're going to be putting together right here is going to be a very, very basic framework for a very, very basic application that will allow for some very, very basic communication between multiple clients.
There was one last question on the infrastructure you've got there, which is on event in which direction, essentially? Receiving data from server or sending data from server?
On event is when the server informs the peer that something has happened. On operation request is when the client asks the server to do something.
So on operation response, that's in the other.
On operation response, I'm not going to be using. And I'm going to be talking really quickly about the decisions that are going to be leading up into the basic framework we're going to be putting together here in a few seconds. But basically, when on an operation request, the server can send back information. It's just a convenient way to send back information directly to the client. That being said, let's talk really quickly about serialization. Serialization is a very, very, very important concept to understand when we're working in network code. And there are a variety of trade-offs, a variety of different categories of trade-offs, and a variety of different ways that have different categories and different kinds of trade-offs when doing serialization. When I say serialization, I mean how do we send data between the client and the server? An abstraction that I've been using, and that is a very common abstraction in the world of network programming and in fact, programming in general, is the concept of a command and the concept of an event. A command is the client commanding the server to do something, and an event is the server saying that something has changed on it and the client needs to be aware of it. What I'm going to be doing is I am not going to be interacting directly or to a large extent with the mechanisms that Photon exposes to us for serialization. And the reason being is that they're very verbose.
And presumably that would require a wider knowledge. I don't mean the programmer's wider. I mean that would require more of your program knowing about Photon.
Right. Basically, if I still wanted to keep everything hidden behind server connection, this would become a very, very large method. Because it would say, okay, if the event code is this, then this parameter is this, and this parameter is that, and it gets very, very long very, very quickly. So instead what I'm going to do is I'm going to make things very straightforward instead, where we will be basically passing DTOs from the server to the client, and we will be using JSON to deserialize and serialize them. Now, I know what people are going to be saying if they know what JSON is, and why would you use JSON? Well, the only answer that I have is that it is the simplest serialization way to do serialization with a particular library that is available via NuGet. However, for a production level real-time game, you do not want to do that. You want to use a binary serialization format. That being said, working with a binary serialization format bearable is something that has a significant time investment. The best of both worlds is when you use dynamic code compilation to actually basically write the code for you using reflection at the start of your program to do the serialization and deserialization. But obviously that goes far beyond what we can even possibly hope to express in the course of another hour or two.
Oh. I thought that'd be in here. That's a shame. Never mind.
No, we're just going to be talking about JSON.NET because it is a library that I know for a fact works. We will be sending JSON between the server and the client and serializing them on both ends, which means we need the JSON.NET package, which Sadly, I just realized NuGet is not installed on my thing. So I'm going to go ahead and install the NuGet package manager. What?
Eventually.
Oh, that's actually not what I wanted to install.
That's the wrong thing, dear boy.
Indeed it is. Where are you, Mr. NuGet? Don't tell me that NuGet doesn't exist on... No.
NuGet doesn't exist on.
It wouldn't surprise me, and it would really suck.
That is funny.
Hold on.
I saw an unit mentioned there.
I know.
Given the difference in usability, I wouldn't be at all surprised if they kept that for the paid version. Do you want to pause the video for a second?
Yeah. And okay, and we're back. So yeah, Visual Studio 2010 Express does not support NuGet. However, if you are following along in a full version of Visual Studio, what you should do is right-click your references of your project, and remember that project in your case is going to be PhotonTest.Client. Go to Manage NuGet Packages. Go to Online, and wait a year, and then type in JSON in the search. JSON. And you'll get a nice little package near the top called JSON.net. Hit the install button, and you will have that installed into your project. What I've done, however, just so we can move forward with this in Express.
I'm sorry, I wanted you to. I thought you were going to say this on video about how to get NuGet in the first place.
It should. Well, to get it in the first place, you just have to go to Tools, Extension Manager. And if you go to Online Gallery, it should be near the top. Yep, it is the most highest rated extension to Visual Studio. And just install that via this. And it does come with the... NuGet's going to be built into Visual Studio from here on out, so it does come with the newest version of Visual Studio. For now, however, what I've done is I've copied over the JSON.NET DLL into my local library folder within my solution. So now all I have to do is go to PhotonTest.Client, References, Add Reference, Browse, and browse to JSON.NET, and add newtonsoft.json.dll, and JSON is now on my computer. Okay, so again, basic serialization. We're not going to be using the Photon serialization because it's very, or not explicitly, because it's very verbose. However, sometimes when you get to the point where you really need to squeeze out the most performance as you can, verbosity is something that is something you can trade off for performance in certain cases. Although the best scenario is dynamic code compilation for the serialization. What we're basically going to be doing is sending in a string of JSON, and again, JSON is a text serialization format. Okay. So let's talk about, so we have our commands and events. We've talked about commands and events. I'm going to go ahead and inside of PhotonTest.Base, I'm going to add a folder called abstract. I'm going to add two interfaces to it. iCommand and no alt insert, of course. iEvent. These interfaces will not have anything on them right now. They're just used to mark a object as a command or an event. So let's talk about the first command that we're going to be sending. The first command that we're going to be sending to the server is going to be the login command. So how do we represent commands? Again, because of the way I'm doing serialization, it's a really nice sort of way of doing things where I just need to represent commands and events as simple objects. I'm going to place the commands under a namespace called commands, and it's important to note that I am in the PhotonTest.Base project. That's because the client and the server need to be aware of both the events and commands that can be communicated with.
So that makes sense. So the base project is essentially like a bridging project for anything that's needed in both.
Yep. And it's also a place for like utility methods that you might want to place and have access to through both.
Okay, cool.
So the first command I'm going to create is going to be login command. I suffix every command with the word command, and I suffix every event with the word event. It makes things very straightforward. Okay, so I'm going to go ahead and make sure that my command and events are all publicly accessible.
I like to prefix with common words myself, because that makes sorting even easier. But anyway, just thought I'd throw that in while you were typing.
Okay, so what's login command going to be doing? Remember, the commands represent data, and that's all they do. They're packages of data. And what's the data for the login command? How about player name? Oh, this is going to be so much fun with that alt insert or alt inner. Okay, so here's our first command, the login command. Basically, in order to facilitate our client communicating with our server, we simply need a mechanism in which we can dispatch this command from the client side and have it received and deserialized on the server side. I'm going to go ahead and create an interface in my PhotonTest.client. I'm going to create an interface called Command Dispatcher. This is simply a design that I like expressing.
Are you being attacked by a parrot?
No, there's birds.
Wow.
So basically, oh, are you kidding me? Okay, I'm going to have to add a reference to my base project. So what I just did was I added a reference to my base project from both my client and my server.
Sorry, just because this confuses me. Which ones reference which here out of these three?
Photon test server references base and client references base. Those are the only relationships.
Okay.
I did get a question, will JSON.NET be able to deserialize this? And the answer is yes, which is why I love using JSON.NET, because it's very simple, straightforward, and intelligent. JSON.NET will properly match, or when it goes to serialize the login command, it'll result in JSON that looks like this. This is what the JSON will look like. When it goes to deserialize it, it'll match up the properties with parameters to the constructor, which means that the parameters to the constructor need to match the parameters or the property names. Now, you should be doing this anyway, but if you're going to be serializing with JSON.NET, this is a requirement.
Just as an aside, am I losing my mind, or did you not already do a specific JSON video with something? And if so, which set was it in?
Well, I think we wrote a JSON parser in the AST Antler stuff.
Cool. Yes, somewhere there are JSON videos available on the site. Well, there you see, they're talking to us. This is what happens if you serialize JSON. He makes me jump.
But yeah, so and I want to point out, I could have simply just made this public set, but I prefer the immutable format. And it's also nicer with the constructor than having to use object initialization syntax.
Cool.
Okay, so now let's talk about the command dispatcher. What is the command dispatcher? It is simply an interface with a single method called dispatch that takes in a command. The only reason I have this interface here is because I am going to have my server connection implement command dispatcher. Somewhere. Or am I just blind? There you are. Okay, so I'm going to have the server connection implement our command dispatcher. So is everybody following along up to this point? We have on our server connection class, remember our server connection class is the abstraction over Photon. And we have a dispatch method. This dispatch method is going to serialize our command and send it through the peer to the server. So I'm going to say peer.op custom. Op custom is the method that you use to send in information from the client to the server. Operation code is going to be irrelevant. I'm just going to use an operation code of 1, although that is going to be ignored. I'm going to go ahead and initialize a new dictionary. Well, actually, let's talk about the signature first. We have an opcode, which we've talked about before, a dictionary of byte and object, which will be again serialized by Photon and sent to the server and unpackaged, and then send reliable, which send reliable is irrelevant on TCP, but on UDP, if you set send reliable to true, Photon will do some additional validation to ensure that the packet was properly received. When using JSON versus a binary serialization, what type of file size difference are we talking about in regards to a chat program? In regards to a chat program, getting away with JSON.NET would be completely acceptable. In regards to a real-time FPS, it would not be. Basically, when you are working under every byte that you send is additional time and latency. And you want to prevent sending as many bytes as you want. That being said, if this was a workshop about serialization, we wouldn't even be able to get to a functioning program. So I'm simply doing what will allow us to move forward, and actually coming up with a proper binary serialization format could be the subject of another workshop or your own exploration. However, this will work.
I imagine Hector's question probably falls into that same outside of the scope, but
yeah, how is that even possible? Getting sure how is it even possible getting sure you receive a UDP packet? It's possible because Photon implements aspects of TCP in software. It's just a wrapper around UDP that adds in functionality. I mean, ensuring that you get a UDP packet, doing that is the same way as you ensure that you get a TCP packet. But the difference is that TCP handles that at a protocol level and not at an application level.
We'll have to get into that more in a general networking class, I think. Cool. So where do we go from here?
Okay, so I'm going to send in a dictionary of byte and object. The first item in the dictionary, I'm going to give it a key of 0 and a value of command get type assembly qualified name. I'm also going to add another key of 1, and this is going to be JsonConvert dot serialize object command. So what we're sending to the server is the assembly qualified type name in the form of a string, and then the actual JSON that represents that object. With these 2 bits of information, the server can properly reconstruct this entire object on the server side. Meaning, by using a serialization engine like this, we have reduced the amount of work we have to do per operation to a significant degree, where we can reuse this class on both the server and the client. Okay, so now that we have this done, let's go ahead and I'm going to go ahead and implement the command handler on the server, and then we're going to take a quick step back and write our client in a little cleaner way, and we'll talk about that in a second.
Cool.
Okay, so the Photon test server, remember, when op custom gets sent in, so when line 42 gets executed, ultimately, after Photon does all of its magic on the server side, on operation request will be invoked. Which means the only thing we have to do here is the exact opposite of what we did back there. So I'm going to do this. Var command equals I command JsonConvert, which I'm going to have to pull in a reference to JSON.NET on the server. JsonConvert dot deserialize object. Now the deserialize object takes in 2 parameters potentially. It does have a generic version, but the most important version is this one, which takes in the actual JSON as well as the type that we're expecting. So what's the actual JSON? It's going to be cast to a string operation request dot parameters at key 1. What's the type? The type is going to be type dot get type cast into a string, operation request dot parameters at 0. And then I'm missing a
Very nice.
parenthesis. So you'll notice that this is the complete opposite of what we did right here.
Which makes sense, because it's just like using a stream reader, stream writer pair, or a binary reader, binary writer pair. You write what things in, and you read things in one order, and you write them out in the same order.
Yep. So, so the first thing we pass in is the JSON. The second thing we pass in is the type. But we have to convert the type into a type from a string. And you can do that with the type.getType method that takes in the string name of an assembly qualified type. An assembly qualified type is a type that includes the namespace, the type name, and the assembly of where to locate that type. Okay, so now how do we respond to this? Well, there's a variety of ways. The first thing I'm going to do is I'm going to open up a try block.
We go, whoa! That's how I respond.
Okay, so the first thing I'm going to do is I'm going to say log.debug format command executed. Okay, so this right here is where I'm going to actually process the command. Now, there are very clever ways of doing this using generics and reflection and really cool things, but I'm going to make things very manual for right now. I'm going to go ahead and say,
Equality operators.
now, you know what I'm going to do?
Please tell me equality operators.
Remember when I said that I will not hold off doing something slightly advanced if it saves me a ridiculous amount of typing?
What are you doing?
Everybody gets to actually see an example of that. This will save us a lot of time.
Well, you see, you know my thinking on this. Generally speaking, for these courses, these are not beginner-level courses, and there's no point in teaching people the oversimplified way if a little bit of effort on their part will enable them to understand the way you would do it.
Right.
I'll tell you if it gets too complicated to understand.
Well, understanding of what's going on should be relatively easy. Understanding the actual syntax used might be a little bit more complicated. But what I have is a dictionary of type and action of command, which means I have a dictionary that maps a type, which is going to be all my command types, to executable code that takes in an I command. Then, for every command, I'm going to manually add a method to my peer called handle, given a particular command object. And then I'm going to have my dictionary map from the type of a login command to a lambda that will invoke the appropriate handle method. So,
this is a lovely bit of syntax, I've decided.
Yeah, I personally like this quite a bit. So basically, you don't have to worry necessarily about what's going on here, delegates, lambdas, blah, blah, blah. Just remember, the code I'm about to write using this dictionary will invoke the login command if a login command was deserialized from the client. So I'm going to go ahead and do...
And for more, wait. And for more about lambdas and all of this type of very cool stuff, make sure you check out C# 103.
I was about to go there as well. Excellent.
Starting, what is it, next week?
I believe so, yes.
Starting next week.
This is all good stuff. And it is, I mean, because the one thing that's immediately in my head, and I imagine Nelson knows that, is input handling.
Yeah.
This is wonderful for hotkeys and tying actions to hotkeys, and oh, I love it. I'm not really good at it, but I do like it. I'm trying to use it.
And thank you very much, Flash. And Dave, you're absolutely right. You can also check out the C# reference videos, also available over at 3dbuzz.com. Back to you, Nelson.
Number one never did exist.
Yeah.
One of these days we'll get around to recording that. You know how that goes. The introduction wasn't that important to us.
Okay, so this bit of code looks, actually I really like it, but it might look confusing to people who are not familiar with delegates. Again, all this code does has two important attributes to it. First of all, it will invoke whatever we've registered as the method to invoke given a command, or it'll throw an exception if that type isn't found within our dictionary, which is why I'm purposefully not using try get value. I'm purposely using the indexer because that'll throw a nice little exception, which will be handled here on line 44, and it'll be printed out to our logs. Okay, so what am I going to do in a login command? Right now, all I'm going to do is log something out. Log debug format logged in command dot you piece of Visual Studio
Piece of code.
I accidentally hit a command that made it automatically generate a class called login command on my server. Obviously, that's not what I want. I wanted the login command that's defined in the base project, which I just imported. Okay, so now I'll do command.playerName. All right, so now what I'm going to do. I am going to be working on the client a little bit. I'm going to be putting together, in front of you guys, a nice little, really basic client framework that will make dealing with networking a lot easier. But for right now, I'm going to kind of cheat. I'm going to say connection.connect, and then I'm going to say thread.sleep 500. And then I'm going to say connection.dispatch new login command. And I'm going to say console.readline. Now, can anybody think of why I have to put a thread.sleep here?
Yes.
Was that Jason or Gavin?
That was me.
Oh.
That was
Well, you know,
because I've asked you before.
After the update, it's quite tired. I mean, and if you just don't let it rest a little bit, then it's going to get all grumpy.
Oh.
On top of which, you get 10% faster experience for 8 hours. I may have been playing Skyrim too much.
All right, so let's go ahead and build out everything.
You're just going to take that as the acceptable answer and move on. That was great. Okie dokie. So moving on.
You never did answer the question, Nelson.
Actually, no. I am running into a slight issue. Hold on.
You failed.
Blah 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 blah. See, I'm running into a small issue. Well, the thread.sleep here is to make sure that we don't get 100% CPU utilization. But what we need to do is we need to invoke the connection.update so it'll actually do the connect before we do the dispatch. So what I'm going to go ahead and do is I'm going to cheat. I'm going to remove this code soon, but I'm going to say on status changed in my iPhoton peer listener. Remember, this is the object that's put into the Photon peer. So on status changed will be invoked when the status of the connection changes. I'm going to say if status code equals status code.connect, then dispatch a new login command. And I'm just doing this to test my login stuff at the moment. So is everybody good with this?
Essentially, you're saying that's going to be thrown away.
Yeah, in a second, but I just want to test my login code first.
I was just thinking, how many times have you done this in your career?
Done.
Surely you should be able to get it right by now. You've built a server.
Yeah.
You just do it once and copy and paste on them.
Well, I do copy and paste quite a bit between applications because there is a little bit of annoying stuff.
I didn't mean that as a bad thing. If you've done it right once, why spend hours typing it out again?
Oh, hold on. Oh, that's because I have this stupid console.readline. Fine, I'll just do Nelson. There we go. Now let's watch us log in. Woo! Peer from connected, Nelson logged in, command login, command executed.
Did you nuke that line that you had before about the key available?
No, that's still there.
Is that not what's causing...
The problem is complicated. It gets into a threading issue. Basically, we're now forced to be put in a situation where we need to have a thread that will be listening to the server, and then another thread that will be handling input. Because input is blocking in .NET. So as a result, if we block our thread, our server never gets updated, and eventually the server will time out.
And so, sorry, I'm unclear on how you've got around that.
I haven't. We're about to.
Okay, I'm lost. Oh, right, okay.
Okay, so I just wanted to prove to everyone that dispatch new login command, this bit of code, plus this bit of code, basically has made it so all we have to do is create new command DTOs, and we can have a very nice, clean, object-oriented communication between servers and clients. So how's everybody feeling about the commands?
Any questions on them?
Because right now we're about to take one quick little detour and make the client work in a way that will prevent us from these blocking issues. Or prevent us from dealing with these blocking issues. Okay, so let's go ahead and do that right now. I'm going to go ahead and create an engine class on the client. The engine class is going to be responsible for, well, being the engine. I'm going to go ahead and create a few interfaces.
Would this be conceptually your sort of game manager?
Yes, actually. Okay, so our iEngine is going to have two methods on it. It's going to have
update and on GUI. No?
Switch controller and quit. Our iController is going to have one method on it called void hit, or two methods on it, iEvent event, and process input.
Oh dear Lord.
Okay, so basic stuff so we do not have to deal with these threading issues, because that's what I want to get away or fix, because that's a very big problem in terms of working with Photon. Finally, I'm going to add another interface onto my base folder, or my base project, called iEvent Dispatcher, or iEvent Publisher. This isn't a very particularly fancy interface. It just exists as a nice way to hide things in a clean way. All it's going to have is a publish method.
And the app and the app there is because event is a keyword.
Yeah, if I didn't have the at here, we would get a nice compilation error. Okay, so now that we have our engine and our controller and our iEvent Publisher done, I'm going to go ahead and have engine implement iEvent Publisher and iEngine. And basically what we're going to do here is we're going to write, the engine class is going to be responsible for handling the threads for both user input and for the server. So let's go ahead and put this together. I'll explain all this code in a second.
Volatile. Fantastic. Can you have a nonchalant bool?
Huh?
I was just thinking, if you can have a volatile bool, I would like a nonchalant one. Or an inquisitive bool. Sexual, that sounds like a perfume. Nonchalant by default. Mr. Complicated, yes, that's my reaction on first looking at Nelson's way of doing things. But generally speaking, they only have about 4 lines of code in each, so...
I don't have alt insert. Blah, 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 blah. It'll be just way easier to explain this code all in bulk than...
Yeah. That's why I was just sort of jabbering with the guys who are here, the hardcore attendees who've stuck with us.
Blah, 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 blah. Blah, 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 blah.
That's the other reason I'm letting him carry on so full. He said, it is my suspicion that this class is not near a conclusion.
No, it is. Once we get this basic little thing in place, again, this is just a way to deal with the problems of networked code. We need multiple threads. We need something to manage that relationship. So basically what I'm going to have here is inside my engine, we're going to have two threads running. We're going to lock up the main thread, and we're going to start the server thread. So I'm going to say while is running, var input equals console readline, active controller, or current controller, process input. Finally, at the end of this, I'm going to say server thread.join. Now I'm going to implement iEngine and iEventPublisher. The publish method is simply going to say currentController.handleEvent. The quit method is going to say isRunning equals false. And the switch controller is going to say active controller or current controller equals controller. And then finally, inside of the server thread, it's going to be very straightforward. All we're going to be doing is saying while is running server connection dot update thread sleep 10 server connection dot disconnect. Okay, the final thing I'm going to do is I'm going to add a parameter to the server connection.
Sorry, it's disconnecting. You just added a disconnect in there.
Yeah. After it gets done with the while loop. So once is running is false, the next thing the thread will do is disconnect the server and then end. Okay, so that is my server connection. Server connection is going to take an iEventPublisher. Here's why. When the server connection receives an event from the server, it's going to deserialize it and then shoot that event along to whatever the event publisher is set to, whatever was assigned to during construction. Okay, so let's back up, go into program and use our engine, which is simply going to be var engine equals new engine, engine.start. So let's look at the start method. Okay, the first thing we do is we instantiate our server connection. We tell the server connection that we are the event publisher, and we want to connect to this IP address, and we want to connect to this application name. The next thing we do is we instantiate a thread. This code inside of these curly braces is a multi-line lambda that's going to represent the code that is going to run in the thread when the thread is started. Which all we do is we say while is running server connection.update thread.sleep10 and then server connection.disconnect. This has two very important implications. First of all, we can manage our connection to the server independent of receiving input. Because remember, input is blocking. It will block the thread while we do console.readline. We need another thread of execution to continuously update the server. The next implication is when server.connection.update is invoked, peer.service is invoked, which will inevitably invoke iPhotonPeerListener.onEvent, which will inevitably invoke eventPublisher.publish, which will inevitably invoke currentController.handleEvent. The important implication to this is that currentController.handleEvent happens on the server thread and not the UI thread. Okay. So after that, we set isRunning to true. We tell the server to connect, and we start the server thread. By saying serverThread.start, what we're doing is we're invoking this code right here on a separate thread of execution. And then we say while is running. var input equals console.readline, and then current controller.process input. A controller is a very simple abstraction that I created to represent a different state that your program can be in. Because it's a very important aspect to networked programs, is that they very commonly will do completely different things depending on the state of the program.
Yeah, this could be things like main menu controller or a login controller, an in-game controller.
Yep.
Essentially, user input, any sort of controller, really.
Yep. And all a controller is responsible for in this architecture is handling events from the server and processing input from the user.
Such that obviously, if you're on a save game screen and you press W, you want to use the letter W. If you're in game, you probably want to move forward.
Right. So, like in this case, we'll have a login controller that will allow you to type in your username, but then a room controller that will allow you to chat. Okay, so now jumping back into Engine, volatile. Private volatile bool is running. The volatile modifier makes it so that this this variable does not get placed, does not get stale on the CPU cache between two threads, because each thread is going to have its own cache if it's running on separate cores, and which means that the cache is going to have cached, potentially, the same bit of memory between the two. The volatile keyword indicates to the CLR that it is not appropriate for this variable to be cached in the context of a read-only cache. We want to be able to write to is running, and then have the other threads immediately know that is running has been written to.
It sounds kind of conceptually similar to making it static.
Maybe, but obviously static could still very well be cached independently on both. CPUs.
But in that way, as opposed to.
But I see where you're coming from, because now it's accessible from multiple cores simultaneously.
You're guaranteeing that you're going to have the one value that is correct.
Yep.
No matter where you're accessing it from. From that aspect, I was thinking.
And obviously it is going to slow things down a little bit, but if I didn't have the volatile keyword in it, then the main thread, the UI thread, could set is running to false, and then the server thread might actually continue to think it's running for maybe a period of time before it actually updates its own cache.
Yeah.
Okay. So notice lines 36 and 37. Everybody knows that I very much enjoy placing things on the same lines. We could have very well done current controller.process input, and then inside those parentheses do console.readline. Can anybody guess as to why I am breaking those lines apart? Because I am for a very, very important reason.
You haven't got Resharper to inline your root there.
It might not be immediately obvious to people, but I'm just trying to see if people can kind of sort of work on conceptualizing the architecture that I put together, because the architecture is done. All that's left is to write the actual code. No, we want it to block. Look very closely on between lines 43 and 46.
That does narrow it down. It's got to be line 44.
Yes.
That's the key.
Okay, the answer is that when the controller processes input, it is more than welcome to invoke the switch controller method, thus switching to a different controller. However, the problem with that, or alternatively, I'm sorry, I got that backwards. If an event handler on the server decides to switch the controller while the UI thread is blocking on line 37, what could happen is, if event handler switched the controller to a new controller, the way that it's implemented, the way a low-level implementation detail of how this implementation of C# is and how this implementation of the CLR is, this reference actually gets cached before the invocation to console.readline, which means that if the controller changes while we're blocking on console.readline, the old controller will be invoked instead. So this is a nice little thing I ran into while I was working with this.
Essentially, I was going to say, presumably, essentially, it goes through from top to bottom in your code, and consequently, it gets to current controller dot process input before it gets to console.readline. In the other case, where you've got it inline, and then it goes, all right, well, that's
the object.
What we've got so far. I'll put that there and come back to it with the relevant information.
Yeah, it's most likely an optimization. Although the actual behavior of this, I highly doubt is defined in any specification. I just found that in this particular implementation of .NET, the behavior was not ideal.
Cool.
Okay, so finally we have the switch controller method, which will allow us to switch the current controller. And then we have a quit method that'll set isRunning to false. When isRunning is set to false, two things happen simultaneously, potentially. This while loop exits, and the server is disconnected, or the client's disconnected. At the same time, this while loop exits, but then we hit this server thread.join. Thread.join is a method that will block the current thread that you invoked it on until the thread that you are joining has exited. So server thread.join will block the UI thread and prevent execution of line 41 until the server thread has finished running.
So that just means it gives it time to clean things up before shutting.
Yep. Okay. So how is everybody feeling about our very simple engine? Because this is it. This is the engine. The rest of the code we're going to be writing is going to be actual application logic.
It's going to vary depending on your own needs.
Right. But I figured, you know what, if 59 lines of code makes it bearable to, or makes it not only bearable but pleasant to work with this, it's worth showing people an approach of how to put this together, as opposed to this is how you write network.
This is so much clearer
spaghetti
than
code.
Yeah, for sure.
Okay. So let's go ahead and do some fun stuff. I'm going to go ahead and create an event. The funny thing about the event that I'm creating is it's actually, I lied. This event is not going to be dispatched from the server.
No, I don't get it.
The reason this event is not going to be dispatched from the server is it's going to, I want to use the existing event infrastructure to allow my code to detect when the status of the server connection has happened or changed. So I'm going to create a status changed event that's going to take in a status code, which is a photon enumeration representing the current status connection status to the server.
And iEvent, is that .NET? Is that Photon? Is that
That's me.
you?
I made the iEvent interface up here. It's just a marker. So that
funnily enough, I had looked down your solution, but it was closed away.
Yeah, it's so that the void publish methods, instead of taking object event, it takes in something that speaks more to what it actually does.
Cool.
Okay, so how am I going to publish this status changed event? Remember, I passed into my server connection a iEvent publisher, which is ultimately going to be set to the engine object, which is ultimately going to defer to the current controller. But I can hijack this, and under my onStatusChanged, I can say publisher.publish new status changed event status code. So I've hijacked my eventing infrastructure. So now inside my root controller is the controller that will be active when the engine starts. Notice how when I start my server, I don't actually do it yet. What I should have done is this.
I was going to say, it's the first I've heard of this. Now, this name I find slightly confusing. I'm not saying it's a bad name. It just I think it threw me as to what its purpose is. Root controller.
It's the most ambiguous yet specific name I can think of to represent the concept.
Yeah. That's what I got from it. What exactly is it? Is it because it kind of feels like it ought to be something that you inherit from, or
No, the purpose of the root controller is to listen for the status changing so that we know that we're connected to the server, and then switching off to the next controller in the chain, which in this case will be the login controller.
so it's the first one that gets used.
Yeah. It's not going to really do anything specific to our game logic as much as it's going to just be there when it starts.
Is it something that's running all the time?
No.
And is it special in that it's
This architecture, only one controller is active at a time.
Yeah, that makes more sense.
Okay, so the root controller is when it's activated, it's going to say console.writeLine connecting. Now, I know some people are going to grumble about the way that I'm approaching the user interface, but I had to really choose what I wanted to spend time doing during this workshop, and actually writing a framework for making console input bearable was not high on the list. So the actual console input-output will be very simple, but that's certainly something people can play with later.
That's just view code.
Yeah.
He says as if he's been programming MVC for years.
Well, it's true. That is just view code. It really shouldn't be in the controllers, but you know what? Again, that's not the point. The point of this architecture isn't to clean up the separation between the view and the controller as much as to clean the separation up between the server and the client. Anyway, so public void handle. I'm going to say var status changed event equals event as status changed event. And I'm going to say if status changed event does not equal null and status changed event dot status code equals status code dot connect, then engine dot switch controller, and we're going to be switching to a new controller that I'm about to create called the login controller.
You know what I love is anyone who's been through C# 101 and 102, this should start looking very familiar. I mean, this should be looking very familiar, even though we're dealing with Photon and the shape of things.
Okay, so the login controller, I'm going to have a private prompt. Okay, so what's going to happen is when the root controller receives a status changed event, and the status code of the status changed events indicates that we've connected successfully to the server, I'm going to switch a controller over to the login controller, passing in our engine and our command dispatcher.
That didn't... Oh, sorry.
Okay, so then inside of our login controller, the first thing we'll do is we'll prompt them for their player name. And then when we do process input, what I'm going to do is I'm going to say commands.dispatch new login command, passing input in as the player name. So when this controller is active and the user types in something into the console prompt and hits enter, we'll dispatch a login command. The root controller just ignores input. All right, so let's go ahead and launch this and see what happens. What? I don't know. Okay, so we launch this, connecting. Wow, it didn't connect. Blah, 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 blah. All right, so let's figure out what is going on right here using our handy little debugger. Is running is true. That's important, obviously.
If you go back to your log a second.
I would if my start menu would appear. There we go.
Yeah, your application started this from ages ago.
Well, I haven't done any changes to the server. I mean, what I could do, I suppose, is come here and make a change.
I wondered if that was why.
I highly doubt it, but I will just check it really quickly. That I should have just triggered a restart, so it should be right there. Sweet. And we're still not connecting, so obviously I'm doing something dumb. Which means time to debug. Let's first check our server thread. Our server thread does indeed run into input, and it never does get disconnected. The next thing we're going to check is going to be the IP address. I'm pretty sure that is the appropriate IP address, but let me verify really quickly. Or not IP address, but port. 4530.
Wrong.
Ah, dyslexia. It's 4530, not 4350. Okay, now I've thoroughly embarrassed myself. Let's go ahead and watch this actually work. Connected. Player name, Nelson. Nelson logged in. Das logged in. Fast logged in. And so on, and so on, and so on, and so on.
Sweet. You should totally make it make a menu view now.
I'm actually going to go ahead.
Even if the only option is to quit on it, just to show it.
Well,
actually switching to a different controller.
Yeah, we're going to be switching into room controllers, where rooms will be able to do chat in. Because now we have a basic communication between server and client. The last thing I'm going to do before we go head on to break is I'm going to make the server capable of sending an event to the peer. What I'm going to do is I'm going to create another namespace here called events. Not surprising. And events, then I'm also going to create another namespace called value objects. Inside of value objects, I'm going to go ahead and create a player details object. Player details will simply have a GUID ID and a string name. Okay, so here's our player details, and the lack of Resharper is really slowing me down. I'm going to create...
Just begging for you to need equality members.
I'm not even... No quality members.
Without Resharper, there's a hell on earth.
Okay, I'm going to create a logged in event.
And I know you like it, Mr. Complicated, slowing him down. But the problem is, we've been going for 2.5 hours.
Yes, no.
We have a limited amount of time, and it would be a lot easier if he could hit Alt-Enter.
And Craig, yeah, Resharper really is that good. It's worth every penny and more as far as I'm concerned.
Single biggest improvement to your workflow, guaranteed. It is amazing. And it'll teach you programming. Anyway.
Not to mention, Craig, if you get a hold of Zach, you can get a free license for it right now. That's good for still mostly a year. Worth doing.
Okay, so what I have here is a logged in event and a login failed event. These will be sent to the client depending on if the login succeeded or if the login failed. I hope that much is relatively straightforward. Over in my client, I'm going to jump into my login controller and I'm going to handle the case of a failure. Really quickly, I'm going to say if event is login failed event, then say console write line login failed prompt. I'm also going to prompt after commit or after the input's processed as well, so we get that player name prompt again. I'm also going to say if string is null or white space input console write line invalid player name otherwise commands dispatch. All right, so the last thing I want to do really quickly before break is I want to go ahead and make it so that when I do a commands.dispatch new login command, that the server can actually send an event back and using the magic of our server connection class, have it ultimately invoke this code right here. So how do we do that? Well, pretty much the exact same way we did the events. So I'm going to jump into my peer, or our commands. So I'm going to jump into the peer, and I'm going to have the peer implement, or maybe, should I? Nah, I probably should. No, I think I have to, actually, never mind. I want to. I'm going to have it implement iEventPublisher. So a peer can publish events. And the method publish is going to look like this. It's going to be very straightforward. Instead of doing peer.opcustom, we're going to be doing sendEvent. Now, sendEvent takes in two parameters. It takes in the event data and the send parameters. So what I'm going to be doing here is I'm going to be instantiating, I'm actually just going to nuke all this stuff out, just do it manually. I'm going to be instantiating an event data structure, passing in one as the event code, and then a new dictionary of byte and object as the data. Then, after that, I'm going to close that out, and I'm going to pass in new send parameters, and I'm going to say unreliable equals false for the send parameters. So I'm going to go ahead and format this so it doesn't look like misery. Okay. And then the dictionary is going to look like just like what we had before. 0 is going to be event.getType.assembly qualified name. 1 is going to be JsonConvert serialize object event. So this should look very familiar to everyone. Finally, I'm going to say log.debug format publishing blah to blah. Okay, very straightforward code. So now let's go ahead and reciprocate this on the server connection class, which is basically going to do the opposite. So let's jump into server connection.
Or the reciprocal.
Whatever. OnEvent is the method that's going to be invoked after Photon does all of it. So sendEvent is going to be sent to Photon. Photon's going to do its magic, package this up, shoot it over the internet, and end up invoking this method right here, OnEvent, on our client. So what do we have to do? Well, it's very straightforward. Publisher.publish iEvent JsonConvert deserialize object string event data parameters 1, and then finally the type, which is going to be type get type string event data parameters 0. And let me go ahead and format this a little bit nicer. What is this code doing? Well, it's doing the exact same thing that the command code did on the previous thing. It's saying go ahead and deserialize the event that was passed in using the first parameter as the type and the second parameter as the JSON data. Send that off as an iEvent into the event publisher. Remember, the event publisher is the class that's passed into the constructor of our server connection, which is ultimately going to be our engine. Our engine is an event publisher, and it passes itself into the server connection. So ultimately what happens is, at the end of the day, here's the flow of data. We start with, actually I'm just going to make this example even better. Inside of my login command, I'm going to say publish new login failed event. Okay, so let's round trip this really fast before we run this and verify that it doesn't work, because it probably won't, knowing my luck. First thing that happens is that the controllers process in, well, let's back up even further. The engine on the UI thread will get input from the console, and it'll tell the current controller to process that input. When the login controller is active, that's going to result in the method on line 34 being invoked, process input. Process input is going to make sure that the string is valid, and if it is, it's going to say commands.dispatch new login command. What's commands? Well, commands is an object that implements iCommandDispatcher, which ultimately is going to be our server connection. So the code goes from line 39 right here all the way to line 46 right here on this dispatch method. This dispatch method tells the Photon peer to process this event, the serialized event, or the serialized command. This is where Photon gets involved, and my code's no longer involved. But once Photon gets done doing what it's doing, it's going to jump all the way here to onOperationRequest on the server, deserialize the command, and then invoke the command. And when the command becomes invoked, the method right here gets invoked, line 31, because we wired that up in our dictionary. Line 31 says publish new login failed event. When this happens, we jump into our publish method, which sends an event back to the client as a serialized event object. So this again is where Photon now is in control of everything. So now we jump into our server connection on the onEvent method. So this is what eventually Photon's going to invoke on the client. This says publisher.publish deserialized event. What's the publisher? Well, again, remember, the publisher is going to be the engine. The engine's publish method gets invoked. When the engine's publish method gets invoked, we tell the current controller that an event has happened. When we tell the login controller that an event has happened and it's a login failed event, we get a message on the console saying login failed.
So show us a magic trick then.
Actually, hold on. I should probably wait. That should have triggered a application restart, I think. Maybe it did. That should. Okay. So let's go ahead and run this. Login failed. Login failed. Actually, I'm going to make this a little bit better because of the latency. I can do a little bit better than this.
There's quite a lot of lag between us and the video. I mean, us and you as well now that you're pinging.
I'm going to say if we're currently in a login, don't process any input. Okay, so this will make things a little bit nicer.
The video's frozen up at my end.
Hello?
Can you hear me?
Can you hear me?
The video.
It's still running
Yes.
on mine. Oh. It's still working on mine, still working on one at least, and others.
Probably just bandwidth, but I may be about to go boom.
Okay, so now we have code that's working. All right, I'm going to go ahead and go on break for right now. And then after that, we're going to finish up our application implementation. But I hope everyone sees what's going on at this point. So, and we're back. So we have some interesting round tripping at this point between the client and the server. However, I didn't want to leave people with just having a login system because there is a little bit of code that we can add to this to make the application a little bit more interesting. Obviously, we do not have any communication between different clients at this point. They just connect to the server, but they don't talk to each other. So what I'm going to go ahead and do is I'm going to add in a variety of events and commands into the system, and then I'm going to implement the command handlers on the server side, implement the event handlers on the client side. So let's go ahead and get that started. Okay.
Come on then.
So what I'm going to be modeling is a multi-room chat application. We're going to have 3 commands total. We're going to have a join room command, a login command, and a send message command. We already have the join or the login command, so let's go ahead and add in our join room command. The join room command is going to be very straightforward. It's simply going to say public join room command string room name. Okay, very straightforward. Client sends in a join room command, he gets moved into another room. Finally, we're going to have a send message command. What's the send message command going to do? Well, it's going to send a message. When the send message command comes in, we're going to have the client send a message to everybody in the room that he's currently in. Okay, so that's going to be the extent of the interaction our client has with the server, but what about the interaction that our server has with the client? Remember, those are handled by events. The server is going to be sending events to the different peers to let them know that something happened in the system. So I'm going to go ahead and create a few interesting events. I'm going to create a join or room joined event, which can be very straightforward. This is going to be sent to the clients that join a room. What's it going to have? It's going to have a string room name and an IEnumerable of player details.
Best sound effect ever.
Well, yeah, there we go. Take note that I'm making very certain that the names of the parameters match up to the names of the properties. This is a requirement for having this properly being serialized and deserialized by JSON.NET. Okay, so we have our room joined event, but what else do we need? We need a player entered room event and a player left room event, because once a user is already in a room, he needs to be made aware of when a player enters and leaves. So, when a player enters a room, that's not how you spell enters, is it? It enters.
An ed. Remove the second E. E-N-T-E-R-E-D. Oh dear lord.
What? My copy paste doesn't work. Okay. Second E? No. Entered.
Yes, done. Anybody think you didn't finish high school?
I've never misspelled entered before. This is actually a first for that one. And it doesn't really matter because I always use spell checking anyway for all my schoolwork.
Go and Alt-Enter into your file name, correct.
Okay, so we have a player entered room event, and we also need a player left room event, so that the server can tell the clients when a player has left. All this is going to have is, remember how I'm representing the player IDs with GUIDs. So all this event needs is a GUID of the player ID that has left the room. The last event we need is a message sent event, which is going to happen when a player sends a message to another or to the room that he's in. This is going to have to contain the player ID
And presumably who he's targeting.
message
And the message.
And how about when it was sent? Okay, so now that we have our message send event, player left room, player entered room, and entered room, why didn't the file name update? We have all of our events now done. So this is the extent of the communication protocol between the server and the client. Now, I highly encourage people who will be following along later after watching this video, or maybe who are following along now, that what we have here is a very nice starting point for a variety of different kinds of games, and that are not necessarily tied to the console. Notice how, and this is a very important thing that I don't know if people have noticed or not, but notice how none of what I've been doing is tied to the console. The server never tells the client what to display. That's a common mistake I see with a lot of people who are working with console-based networked applications, where they have the server telling the client exactly what and how to present information. That's not how you should ever model events. Instead, you should model events in a more abstract sense that can be applied to any engine. In fact, we could very easily take this code and import it over to Unity without changing the server whatsoever. Okay. So now let's go ahead and put together our server. What's going to be in our server? The server is going to be very straightforward. I'm going to have a model namespace. And the model namespace is going to have a player and a room, because that's basically our model. These are our nice little game objects. So, what is a player? Well, a player has an ID, well, specifically has a player details. It also has a current room. Now, the player constructor is going to take in a player details and an IEvent publisher. Okay, so what's going to be on the player model? Well, it's going to be very straightforward. We're going to have two methods. We're going to have a publish method that simply defers to our event publisher. And we're going to have a enter room method that simply updates our current room. Now, what's important about this is a player is the abstraction over a peer. But it's abstraction over a peer in a particular context. This is what I was talking about before, where somebody suggested, oh, won't you have an admin peer and a player peer and another peer? And no, you wouldn't. You would still always have just one peer class. But when the context of the peer changes, as in they authenticate themselves, then they can be represented with more appropriate models. So we can have a player class that wraps around a peer in the form of having a reference to an event publisher. So when we say, publish this event to this player, that gets deferred to the low-level peer object. Okay, so what's a room? Room's going to be very straightforward as well. We're going to have a private read-only dictionary of GUID and player, a public string name, and then a public IEnumerable of players that simply returns players.values. So we can get a list of players from the room. When we construct the room, we give it a name, and we instantiate our players dictionary. We need a few other methods, though. We need an add player method. We need a remove player method. We need a send message method. And I'm going to go ahead and create a private void publish to all method. What's publish to all going to do? Publish to all is simply going to loop through all of our players and say player.publish event.
See, I was wondering about on line 30. Is that the target player or the player it's from?
Player it's from. Messages are global in this system, but there's nothing stopping you from adding that feature.
Okay.
Okay, so what's the add player method going to look like? Now we have to think, because this is server code, we need to think, how do we tell the player that they just joined a room? How do we inform them of all of the data that is available to them in the room? And then how do we inform everybody else that they have entered the room? What I'm going to do is I'm going to say player.publish new join or room joined event. I'm going to pass in the name of our current room as well as players.select p.details. And then I'm going to do .toList so it doesn't do that over and over again if it gets enumerated multiple times by JSON.NET. So when a player is added to a room, he is informed by the server of the room name as well as all the players that are in the room.
I was wondering why you didn't enforce it outputting a list.
You mean do that .toList in the constructor of the event?
In the getter of players.
Oh, that's fine because I don't need a .toList here really. This just returns a value collection. It's not a link statement.
Yeah.
Okay, and then after we tell the player that they've joined the room, we want to tell everybody else that a player has entered the room, which is simply going to be player entered room event player.details. Then we're going to say players.add player details ID and player. And then we're going to tell the player to enter us. There's a few important aspects to this. Notice how I say the publish to all player entered room event before I add it to the player's dictionary. That's important because I don't want the player to, because the player knows who he is. He doesn't need to be made aware of that he's entered a room. He needs to be aware of that he's joined a room. And there's a difference because when you join a room, you need to know the retroactive state of what you just joined. But if you're already in the room, all you need to know is what's changed. So that's the difference. The person who enters the room gets informed of everything, and then everybody other than the person who just entered the room just gets informed that a new player has entered the room. And then we add that players to that list. Okay, what's remove player going to do?
Make a giraffe appear on Mars.
No. It's just going to say publish to all player left room event player details ID, and then it's going to say players remove player.id details.id. Okay, what's send message going to do? It's going to say publish to all new message sent event. I bet you guys didn't see that coming.
I don't know. It took me by surprise.
So when a message is sent, we just turn around and tell everybody in the room that a message has been sent. Okay,
nice.
We need one more class. This class is going to be called the engine, which is going to be the server-side engine. And he's going to have some responsibilities. He's going to have overarching responsibilities that aren't applicable to a room or a player. First thing I'm going to do is something that I'm not going to explain just yet.
I can't believe you're calling it engine as well.
Yes, because it's the engine.
Well, what's the engine then?
The engine is going to be the code responsible for negotiating between players and rooms. He's going to have all the game logic for a player in the context of the entire system, whereas a room only has the game logic for a player in the context of a room. So think about the hierarchy. You have the engine, which knows about all the rooms and all the players, and then the rooms, which just know about what players are in them. So we're going to create a few different fields here. Okay, so we have a reference to the lobby room. The lobby room is going to be the room that a player is automatically joined into when he joins the system. Then we'll have a dictionary of all the other rooms, and then we'll have a hash set of player names. Why am I having a hash set of player names? Well, I want to ensure that no two players can have the same name in the system. So that's how I'm going to keep track of that information. The instance constructor is simply going to instantiate the lobby, instantiate the rooms. However, here's the important aspect. Here's the logic that I'm trying to represent. If a player joins a room called other room, and that room doesn't exist, I want to create it. When the last player leaves a room, I want that room to be destroyed. However, I want room names to be case insensitive, so I'm going to use a neat little feature of the dictionary constructor to pass in an iEquality compare of type string, because that is the key. And I'm going to pass in string compare .current culture ignore case. By passing in this iEquality compare, we make all of our dictionary keys case insensitive. Then I'm going to go ahead and do the same thing with player names. And again, I'm going to be passing in a string compare .current culture ignore case so that our player names are case insensitive as well. Finally, I'm going to invoke a method that doesn't exist yet called add room, and I'm going to pass in the lobby. So let's go ahead and implement add room.
Now we do have a question before you get too far over in the question panel.
Yes, Hector asked, wouldn't using their GUID make them
They
unique?
would. I wanted to show an example of being able to reject a player based off a certain criteria. So I chose as an arbitrary thing to demonstrate that functionality that I would decide that all player names need to be unique. In the real world,
And actually, you'd probably want them. I was going to say you'd probably want them to
unique
be
anyway.
Anyway,
Right.
because otherwise it's going to be very confusing.
Yep. Okay, the add room method is going to be very straightforward. It's going to be rooms.add room ID room. Room. Sorry, room.name room.
Of course, webinar obviously doesn't enforce that, given that we can have two JSONs.
Okay, so what else am I going to put on the engine? The engine is going to represent the overarching functionality of the system. The first thing the engine is going to do is allow a person to create a player. I'm going to make a method called tryCreatePlayer that takes in a name, an iEvent publisher, and has an output player parameter. Then I'm going to say if not player names add name, player equals null, return false. Remember, the hash set add method will return true if it successfully uniquely added the item, and it will return false if the item already exists. So this is how we could indicate to whoever wants to create a player that the player name wasn't unique and we want to return false. Finally, if all goes well, we'll instantiate a new player, passing in the player details. The player details is going to be a GUID, which I'm going to generate with new GUID, and then a name, which is name. And then I'm going to pass in the publisher, and then I'm going to return true. So here's how we create player objects with our system. And here's how the engine is the gatekeeper into each one of our model objects. Okay.
Very nice.
Next thing, we're going to need to be able to add a player. Or add a player to a lobby. So I'm going to do that right there. And then I'm going to say join room, which I haven't implemented yet, player lobby.name. So when we add the player to a lobby, we're just joining room to the lobby name. So then I'm going to say public void join room. This method is going to be interesting because remember, if the room doesn't exist, we want to create it. And then we want to add the player to the room. Furthermore, we want to remove the player from his current room if he's in a room. So now we're going to say if player.currentRoom does not equal null, as in they're already in a room, we're going to say exit current room player, which is a method we haven't implemented yet, but we'll get to that. Then I'm going to say room, if not rooms, try get value, room name, out room, room equals new room, room name, add room, room, which I could easily separate or break out onto its own line. Okay, so if the room doesn't already exist, we add the room. Then we're going to simply say room.addPlayer, player. So remember, this engine class is the gatekeeper into our model, so this is how we're handling the room creation and room deletion. Okay, so now we need to exit the current room. How do we do that? Public void exit current room, player, player. We're going to say if, or sorry, room equals player.current room. If room equals null, throw new invalid operation exception. They're not currently in a room. Whoever called this method was an idiot. Then we're going to say room.remove player, player. And then we're going to say if room.players.eddy or room equals lobby, return. Otherwise, rooms.remove room.name. So what this code does is it gets the current room that the player's in. It checks, makes sure it's not null, removes him from his room, then checks to see if there are any existing players in the room or if the room is the lobby. In that case, it just bails. Otherwise, it removes the room from the dictionary.
Elegant.
Okay. Next, we're going to have a public void destroy player, which is going to be very straightforward. First, I'm going to say if not player names remove player.name or details.name, throw new invalid operation exception, because this doesn't make any sense. If this if statement executes, that means we're trying to destroy a player that hasn't had his name added to the player names hash set, which is obviously a bug.
Sorry, what? So you've got player details.name, trying to remove it from player names, which presumably returns...
It returns true if it removes, it returns false if it doesn't remove, because it does exist.
Right, so we're expecting false.
Yep.
Makes sense.
No, we're expecting true. We're expecting that the player name still contains the name. This also has the side effect of actually removing it from the hash set as well. So this is how we can make sure that when a player disconnects, that name becomes available again. Then we're going to say if player.currentRoom is null, return. Otherwise, exit current room player. Okay, so very straightforward logic. If the player is in a room, then exit them from the room. All right, so that's our engine class. How's everybody feeling about the engine class? Because now all we have to do is integrate our engine class into our peer, and then we're pretty much done with the server. Is everybody still super excited?
Come on, guys, speak up, speak up. Oh, yeah. Do-bo-bo.
Okay, so who's going to instantiate the engine? Well, application seems like a good way to do that, because there's only going to be ever one application instantiation. As a result, we only ever want one engine. So the application instantiates the engine. Now the application needs to send the engine into the peer. So that's what I'm going to do right there. I'm going to pass the engine into the peer's constructor. So if I jump into the peer, I can now add an engine parameter and assign that to a local field. So far, so good?
Mm-hmm. I still find it willfully awkward having two different classes called engine in the same solution. But
okay, the next thing we're going to do is we're going to have each peer is going to have a reference to their player, which at first is going to be null until the login command succeeds. So inside the login command, what I'm going to do is I'm going to say if engine.try, if not engine.tryCreatePlayer, command player name, this out player. Remember, the player needs to know how to send events back into the client that player represents. That's why we pass in the peer in the form of an iEvent publisher. We don't want to pass in a full peer because all we need out of it is the ability to publish events back to the client. So that's why I wrapped it around this interface. And that's why we pass it into the player. So the first thing we do is we try to create a player. If that fails, we'll publish a new login failed event, and then we'll simply return. However, if it succeeds, then what we're going to want to do is we're going to want to say publish new logged in event, passing in the details of our player. Then we're going to want to do engine.addPlayer2Lobby player. So far, so good?
Yep.
Okay, there's two more events or commands that we need to handle. We need to handle send message and join room. So I'm going to say send message command and join room command. And they're going to go to new methods that I'm about to create. So now I'm going to create a private void handle send message command and a private void handle join room command. What's the join room command going to do? Well, it's just simply going to say engine join room player command room name. Because the engine's responsible for all this logic, we can simply defer to the engine once we get that event, or once we get that command. So it's very straightforward. What's the send message command going to do? Well, we're going to go ahead and say player current room send message player command message. I am purposefully allowing for the possibility of a null reference exception right here. Purposefully.
Because that means somebody's doing what they should.
Right. If current room is null, that means the client sent a message before the player joined a room. In which case, I do want an exception to be thrown. And I'm just going to let the null reference exception just fall through and get caught in my logs. But I want to point out that I'm consciously opening up a scenario for an exception to be thrown, because adding the validation would just be if current room is null, throw a new exception, which would be, well, or I could just do this and let it throw an exception anyway. Okay, the final thing that I'm going to be doing here inside of the peer is I'm going to do this. Remember that sync route that I created? Public read-only object sync route equals new object. This object I'm going to be using to synchronize access to the engine. Basically, what I want to happen is I'm single-threading the engine entirely. I'm not worrying about the fact that there is a pool of threads that might be able to handle commands. Because none of the data structures I use in the engine are thread safe, it could be very potentially annoying to have to deal with the multi-threading issues. I did not code the engine to be thread safe, and if I were, that would result in another 4 or 5 hours in this workshop. So instead, I took the easy way out and made the engine single-threaded. However, in a real-time game application, you would have a more complex multi-threading system. But on the same token, multi-threading is a very intense, in-depth topic that requires a lot of consideration. So as opposed to doing that right now and making the workshop last another 5 hours, I'm simply going to make it so that only one thread can execute a command at a time. And this will guarantee that I will not run into errors or exceptions because of the nature of me using non-thread safe collections within my engine.
You're supposed to treat this like a feature. You're saying this gives you backwards compatibility with single processor.
Well, it's just the easy way out, but it's something we will be discussing later. Serialization and multi-threading are two of the biggest things in terms of real-time games. Okay, our server is done.
Hurrah!
Let's write our client. Okay, so what's the client going to do? We're going to introduce a few new classes. Actually, we're going to be introducing 2 new classes. I'm going to introduce another model namespace, and I'm going to add in a room to it. Now, it's important to realize the differentiation between this room class and the room class on the server. The room class on the server is the room model that represents the logic of our system, whereas this model is simply is going to parrot the current state of a room that a player might be in. So I'm going to go ahead and say private read-only dictionary GUID player details players public string name get private set.
So this is like casting mirror image on a room.
Yep. Well, without any logic. That's the important thing. The logic is on the server. The mirror image is on the client, and they're completely different responsibilities and are necessarily different classes. I see people try to shoehorn their classes between clients and servers all the time, and it never works out. The fact is, these 2 classes have completely different responsibilities, although on such a simple application they look similar.
Still think you should have named them differently. It fries my brain.
See ya, Wolfrey. Take care, man.
Oh, bye, Wolf.
Okay, so here's our room, very straightforward class. The next class we're going to be creating is not surprisingly going to be called a room controller. And it's going to represent when the player is in a room, which is fairly straightforward. Okay, the room controller is going to take in a few things into his constructor. It's going to take in a room model, a player details object for the current player, an engine, and a command dispatcher. Okay, so here's our room controller. How does the room controller work? Okay, so in the login controller, now we can handle both a login failed event and a login succeeded event. In the case of a successful login, what I'm going to do is set a player details field to capture the player logging in. So I'm going to say logged in event equals event as logged in event if logged in event does not equal null, then say player details equals logged in event dot details. Now the next event that we want to handle in the login controller, remember how we get shot off into the lobby. However, we need to be aware of at that time or we need to handle the scenario that we receive a join or room joined event so that we can activate the room controller. So I'm going to say room joined event equals event as room joined event. If room joined event does not equal null, then we're going to say engine, switch controller, new room controller, and we're going to pass in a new room. And, well, actually, hold on. We're going to do that up above on a line. I'm going to say var room equals new room, room joined event dot room name. And then I'm going to say for each var player in room joined event dot players, current players, room dot add player, player. So this is how we construct the current state of the system. And then we're going to pass that into the room controller's constructor. We're going to pass in room, player details, engine, commands. Okay, this completes our login controller. How does everybody feel about this?
Shiny.
All the like 2.5 people that are left.
We have a sort of sudden drop-off past the 2-hour mark.
Well, it was always talked about as a 2 to 4 hour. That's what I always heard.
Correct. Yeah. Oh, it's just, yes, we were doing quite well until the last break, and now people have started to drop.
Well, I think we've got a lot of people from overseas that are, it's getting pretty late, like you, yeah.
All right, well, don't worry, guys. We have one more controller to implement, and then we'll have a functional system. So, in the room controller, the first thing I'm going to go ahead and do is I'm going to go ahead and write a method called, or first thing, when it gets instantiated, I'm going to say console writeline, you are now in room blah, room.name. And then I'm going to say list players. List players, not surprisingly, is going to loop over each one of the players in the room and say console writeline player.name. I'm going to say okay, so now we have a list players method that will list all of the players in the current room. So now I'm going to go ahead and implement our process input method first. This is just going to be a bunch of text parsing, so it's not super important. Say if string is null or white space, return. If input at 0 equals /, then process this as a command. Notice how I'm doing input at 0. This might make people cringe. They're like, oh, wait a sec, well, input might be an empty string. Well, we make sure that's not an empty string. And by making sure it's not an empty string, we know that the input has at least one character, which means this input is entirely, or this if statement is entirely safe to perform. It's not going to result in an array out of bounds exception, or an index out of bounds exception. The next thing that we're going to do is we're going to say parts equals input substring 1 split space. The reason I do the substring.1 is so that I eat the slash, and then I split everything else by space. And I'm going to say if parts.length equals 2 and parts 0 equals join, so if they typed in slash join space and then another word, then we're going to say join room parts 1. I haven't implemented join room yet, but we'll see that in a second. Otherwise, if parts.length equals 1, so if they put in a command that was only 1 length, I'm going to say if parts 0 equals quit, then engine.quit. Else if parts 0 equals list, then list players. So, rather straightforward. Finally, at the end of it, otherwise, we'll just do send message input. Now, I kind of broke out the actual dispatching of the commands into their own methods for cleanliness. So let me go ahead and implement these. Send message takes in a message, and is simply going to do commands, dispatch, new, send message command, which remember, this will result in the server having a message being sent by our current client. The join room, however, is going to dispatch new join room command, passing in the room name. Okay, so very straightforward code. Is everybody good with the basic input handling system that we have? All it does is it takes an input from the console, parses it out, decides which commands it needs to send to the server, and then goes on its way.
Well, at least one person's happy. He's proposing you as a new god.
Oh, I actually did see
nice.
that. I did prepare this code. I did do it in one shot, but I did actually prepare it just to make sure that otherwise I would get sidetracked into...
I wasn't going to blow the illusion.
Well, otherwise I would get sidetracked into making the console look all pretty, but I started doing that as I was writing this out, and I was like, no, this isn't going to work. That's going to take way too much time. Okay, so...
Does it work?
Not yet, because we still have to handle events. Now we're processing the inputs and sending commands, but we still have to handle the events from the server. So let's go ahead and do that. We need a few different events that we need to handle. I'm going to go ahead and steal some code. I'm just going to do this again. I'm going to do the event handlers thing, just like we did with the command handlers thing, just to make the code a little bit more straightforward. We're going to do type of join room event. Remember, this happens when we join a new room. I parenthesized that totally wrong. And then we're going to need player entered room event, which I think I accidentally just got a join room event. Yeah, it's actually a room joined event. And then we're going to do a player left room event. And then we're going to do a message sent event. So these are the 4 events that we're going to be handling. Okay, so then inside of our handle method, I'm simply going to say action of type iEvent action if not blah 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 commands, no, event handlers try get value, event get type out action return, otherwise invoke action with the event. So again, this is very similar code to what we had before in the command. I'm going to go ahead and push this all the way to the bottom because this method is going to have to be messed with at all. Okay, so now we need to write 4 handle methods, one for each one of the events that we want to handle. So public void handle room joined event, player entered room event, player left room event, and message sent event. So these are our 4 event handlers. These methods will get invoked when the server publishes these particular events. Okay, the first thing, the joined roomed event, is going to be very easy. The reason it's going to be easy is we pretty much already implemented it. So I'm just going to yank the code from the login, and I'm going to dump it into here.
You said join roomed.
Huh?
You said join roomed.
Oh. Room joined. Okay. So if we're in a room controller and we join in a different room, go ahead and switch to a new instantiation of a room controller with the room that we just joined. I don't feel that that needs too much explanation. Player entered room event is simply going to say room.addPlayer event.playerDetails, and then it's going to say console write line blah join the room event player details name. Player left room event is simply going to say room.remove player event player ID. I'm going to actually go to player equals room get player event player ID, and then I'm going to say console write line blah left the room player name. Huh?
Why is it line 61 you're not using player inside the parens?
Because remove player expects a GUID ID, not a player object.
Okay.
Finally, I'm also going to put in a caveat here. I'm going to say if event.playerID equals current player.id, return.
Yeah.
Okay, final thing is the message sent event, which I'm also going to do if event.playerID equals current player.id, return. Otherwise, console write line blah sed blah room get player event player ID dot name event dot message.
Great if somebody saw all the video up to that point. They can't and couldn't watch the end of the video. They'd just have everything except how to actually make it do anything.
Okay, the last thing I'm going to do is now the client should be done, but I'm going to make the logs a little prettier right now, just a little prettier. When I say publishing blah to blah, I'm going to, instead of saying remote IP, I'm going to say player does not equal null player details name, otherwise remote IP. So if the player's logged in, when it says publishing blah to blah, it'll actually give us the player name instead of just their IP address. And I'm probably going to do the same thing right here as well.
Well, this is the thing. You're logging. You're dealing with logging. It needs to be as any way that you can make it more informative and clearer and easier to look through is important.
Okay, so let's go ahead and...
I actually thought you were going to go with color coding then.
What?
I actually thought you were going to go with color coding.
I don't think this even... Or I think this does maybe support color coding. Okay, so let's go ahead and launch this and see what happens. Nelson, you are now in room lobby. Player list blank. Exception. Oh. You guys let me not instantiate... See, Resharper would gray out this field if you did instantiate it, and then it would underline it if you used it without instantiating it. But the problem was I forgot to instantiate a field. Okay, Nelson, login failed. Login failed. Okay, so obviously what's happening here is it still thinks I'm logged in. However, it says peer Nelson disconnected, timeout disconnect. This leads me to believe that although Photon was made aware that I disconnected, my engine was not. And if I look on disconnect, I never tell the engine that I left. So that means I just have to do engine, destroy player, player. Okay, so now I'm going to do a Control-Shift-B again. Wait for my server to start up. And we're going to try this again. Okay, Nelson, you are now in room lobby. Player list blank. If I do list, I get player list of blank. I can type in messages. Notice the logs right here. This is important. The logs say publishing sent message sent event to Nelson. Send message command executed. So if I go ahead and say join other, it says I'm now in room other. And I can send messages. Now I can say join lobby, and I'm now back in the lobby. And I can say quit, and I quit.
I'm just trying to find the room destroyed.
There's no event that happens when a room is destroyed.
Okay.
Okay, so let's go ahead and fire up multiple clients. Oh, come on. Hold on, I'm going to have to track this down in Windows Explorer and launch it from there to get multiple clients going. All right, let's get some multi-client action going. Okay, so no, come back. There you go.
Featuring Jason Busby on rhythm guitar.
Okay, so
Gavin on the porn horn.
Hey, I've got just because I've got a 6.5 foot horn with an engraved bell.
Okay, so I joined the room, and notice how I cannot log in with the same name. But if I type in Nelson, it says Nelson joined the room. Player list little pip. And if I type stuff in, we see it being represented. Let's get a few other characters going.
If you insist on using ponies, I at least request that you... Now, see, make Calamity log out so that you can log in properly as Calamity.
Who is that guy again? Which one is that? I think it's this guy. Okay, so if I go ahead and have him quit, notice how that he leaves, and then I can go ahead...
No, not Calamity.
Oh, whatever.
Calamity.
Whatever.
Well, you're the one that brings the ponies in.
So now we have, obviously, some network stuff going on. But if I go ahead and join another room, notice how it says I left. Everybody sees that I left. And now when I type, nothing happens. But if I have this guy join another room as well, notice how he now gets made aware of that there's another person in that room, and now that they can see each other. Or now they can see each other. But
and now we have
nice.
we now have console buzznet. Very
That
good,
is
Mr.
fantastic.
Complicated.
And this can be used in such a wide range of situations. This scheme of architecture.
yeah, I really did want to get in some network architecture stuff because ultimately,
Whoa,
Not
sorry.
even networking situations.
yeah,
I mean, this is anything basically where you've got things talking to other things. That's really cool.
okay, so yeah,
Okay.
basically what we put together here today is a
Yes, it is.
very straightforward networking framework built up on top of Photon. So although we are using Photon as a transport mechanism, we have our own little domain specific way to make working with networking code very straightforward. And it deals with a lot of complexity that we do not need to deal with anymore and stuff. And words?
And more words.
So now, as I close out these consoles, you'll notice that people leave. So yeah, so there's not a whole lot. Basically, the only specific logic that has to do with the actual game is handled by our commands, events, controllers, and our model, and our engine. Everything else is repurposable code that can be used in almost any situation, given, of course, that you handle multi-threading and serialization properly, because both of those things, once done in a way that would facilitate a real-time application or a more real-time application, things become a lot more complex. But at the very least, we have a good system in place. Is this code only good for chat and not a game? No, it's certainly great for a game. It's just there's two things that are important to keep in mind when moving from this to a real-time game. When I say real-time game, I mean when player move events are happening 100 times a second. I'm not talking about a card game or a board game or
You mean when you need to know whether somebody's still where the bullet is when it arrives from the person who shot
more
them?
has to do with the volume of the events. Because using JSON serialization is going to decrease the volume of events that you can send substantially. However, it was more than enough to handle board games, card games, chat applications, MUDs, basic RPGs, anything that doesn't
Anything turn-based.
anything turn-based. And to make this architecture work in a more complex real-time scenario, you will have to address serialization, which will result in additional code having to be written, sadly, and you'll have to address multi-threading.
And we are going to have to wrap this up here really soon because Gavin's going to need to jump ship.
Was that Zach popping in just now?
Zach's going to, he's going to be hunting you for...
I thought he was because I'm not on Skype. I turn Skype off when I'm doing these.
Yeah, no, it was him popping in, but he was asking me to get his workshop scheduled for tomorrow. For those of you that want to take they don't have time for the whole course, but you want to take a look at Maya 2013. And I'm going to get that scheduled here in just a minute.
Cool. And yeah, definitely another quick plug, C# 103. Because really, I have to say, this explanation of this, there's very little in here. I think there were a couple of moments that someone would have trouble understanding who's fully comprehended C# 101 and 102.
Yeah, there are a few things I did for convenience sake.
The little bits of link and things like that, and also, just the sheer amount of what you've got going on and what connects to what is what's complicated. Syntactically, events is about the only thing, but the principles should be clear.
Okay, so how's everyone feeling? Further reading materials, resources, any further Photon courses that we do, and of course the C# 103. As far as books and stuff like that, there is a lot of literature online about concerns like multi-threading and serialization. Things like Protobuf, which is a binary serializer made by Google, but has an implementation, 2 implementations in C#, as well as other serialization engines. Please avoid the built-in serialization engines for .NET. They are not suitable for this sort of thing. They are complex and bloated.
Very bloated.
They will hurt your head.
In fact, I did. I mean, just for fun, I could show you guys all something. Show off, rather. Wait a year for Visual Studio to launch. For Unity, go online, check things out for Unity. Unity will have a few more considerations that you'll have to take into account. But we will be doing Photon stuff with Unity. That's always been a major goal. And as far as Unity, the majority of what has been written will work just fine in Unity. Server doesn't need to change at all, and the client only needs to be rewritten in terms of A, wiring it up to work with Unity and multi-threading, and B,
separating out
the view code. But after that, it becomes possible to use this exact same code base in Unity. Oh, come on.
Hector, for me, it works better in C#, but that's because I can't do JavaScript. For somebody who does JavaScript and not C#, they'd probably be better off in JavaScript. Actually, that's not true. They'd be better off learning C# and then using it in C#, but you get the point.
Well, as far as multi-threading, what you really need to do is identify consistent boundaries. You need to identify which bits of the system need to be single-threaded and which can be multi-threaded. And you can solve this using a variety of different mechanisms to do that. But things just become a lot more difficult. Then you have to talk about component scheduling and all this stuff. But anyway, so for Rune Game, the architecture is very, very similar to what we had before. And it took this long to start Visual Studio. Wow.
At this point, I'm going to step out.
Yeah, Zach's waiting for
run
you
away
over
for
there.
a second, and then I will reappear in Zach's class. So, bye guys. Enjoy.
Bye, Gav.
I did end up creating a binary serialization engine. This was a lot of fun to put together, and it's very, very quick. And it can be even faster if I use dynamic code compilation. But with this serialization engine, I got the amount of code needed to, or amount of data needed to represent an event down to an absolute bare minimum. So not only that, it also supports dealing with constructors, just like how JSON.NET works and all that stuff. So yeah, this is definitely a fun thing to put together. Fairly large as far as it goes, a variety of different things. Obviously, when you write your own serialization engine, you have to worry about serializing all the basic types, as well as custom types. But a lot of fun to put together, and it's something that does deserve to be talked about at some point. Anyway, so yeah.
Yeah.
And how's everyone feeling?
I think it was awesome. Very informative workshop. Very intense. Lots of stuff.
Alrighty, so I guess that pretty much wraps it up.
Yeah, it goes way above and beyond what originally I was intending for this workshop to even be. So,
but for people who spend the time to write this out, I hope that people do. And
understanding how to add more features to this code, because this could become a MUD. I mean, it has there's nothing in here that exists that would need to be taken out to represent a MUD. It's just a matter of adding the appropriate events and commands and controllers and other things onto it. So, yeah. I guess that's it.
All right, guys. Well, you guys all have a wonderful evening, and for those of you that are interested in Blender, you are welcome to jump over into Zach's Blender 102 class, which is kicking off right now. And I will get the Maya 2013 workshop for tomorrow scheduled. And for those of you, I did see mention a minute ago about the C# 103 class being possibly 2 weeks. Just the good news is it's not. It's 1, 2, 3, 4 days away. So starting on Monday at 3 p.m. C# 103, and feel free to join us. It's going to be a lot of fun. If you have not been through 101 and 102, please do your best to try to cram through those videos, because otherwise you will be lost. Because it will become a level 103 class. It's going to be interesting. So that's going to wrap things up. Thank you guys for joining us. We do appreciate it. Nelson, awesome job like always. And let's go ahead and conclude this so we can get it encoding and put it up for people. Thanks, guys.